There is an old saying that every civilization leaves behind a legacy, but not every legacy is meant to be understood. Across the ancient world, enormous structures still dominate mountains, deserts, forests and coastlines, surviving long after the societies that created them disappeared. They're among the most carefully built places on Earth, yet many of them remain among the least understood. We know how old they are. We know what they're made of. We can map every wall and measure every stone, yet the questions that matter most continue to resist simple answers. Why was this place chosen? Why was so much effort devoted to its construction? Why did its story suddenly come to an end? Ancient ruins are more than remnants of forgotten civilizations. They are reminders that human history is still filled with chapters waiting to be read, discoveries waiting to be made, and mysteries that refuse to disappear. Rayan Castle rises from the deserts of southeastern Iran like the remains of a civilization that understood engineering far better than history is comfortable admitting. Located near the slopes of Mount Heza in Kerman province, this enormous fortified city was built almost entirely from mud brick, clay, straw and compressed earth. Yet despite standing in one of the harshest environments in the Middle East, near active seismic zones and exposed to centuries of desert erosion, major sections of the fortress survived for nearly 1,000 years. What makes Rayan disturbing to archaeologists is not simply its age. It is the growing realization that many of its engineering solutions resemble principles modern architects only began systematically studying in recent centuries. The ancient citadel was rediscovered and formally documented during archaeological surveys in the 19th and early 20th centuries, after much of the surrounding region declined and populations shifted elsewhere. At first glance, researchers believed Rayan was simply another decaying desert fortress similar to countless abandoned settlements across Iran. But detailed structural analysis revealed something unexpected. The city was not randomly assembled. It had been engineered with astonishing environmental precision. Rayan covers roughly 22,000 square meters and contains residential districts, military quarters, workshops, markets, stables, defensive towers, and a heavily fortified governor's sector. The city functioned like a self-contained machine designed to survive heat, drought, invasion, and time itself. Its walls, in some places over 10 meters high, were constructed using layered adobe techniques that should not have endured centuries of seismic activity. Yet many sections remained standing long enough for engineers to study them in detail. One of the first mysteries surrounding Rayan involves earthquake resistance. Iran sits on multiple active fault systems and experiences frequent destructive earthquakes. Modern reinforced concrete buildings often collapse under severe seismic stress, yet Rayan's ancient mud brick structures displayed unusual resilience. Unlike rigid concrete, adobe possesses a degree of flexibility. During earthquakes, highly rigid materials transfer force violently through the structure, often causing catastrophic failure. But Rayan's thick earthen walls appear to absorb and dissipate energy more gradually. Researchers comparing ancient Persian adobe architecture with modern seismic engineering discovered that the walls were rarely uniform. Some sections taper subtly upward, reducing stress loads higher in the structure. Curved arches and domed ceilings distributed force away from weak corners, while narrow corridors prevented large, unsupported spans from collapsing inward. These are principles now central to earthquake-resistant design. The comparison becomes even stranger when examining nearby Bam Citadel, another massive Iranian adobe fortress. In 2003, the Bam earthquake devastated large portions of the city, killing more than 26,000 people. Yet structural surveys afterward show that certain older construction methods actually resisted seismic collapse better than some later modifications added during modern restoration attempts. This raised uncomfortable questions among engineers. Were ancient Persian builders using empirical knowledge about seismic stability that modern restorations accidentally weakened? Another mystery emerges from Rayan's thermal engineering. Desert climates create brutal environmental extremes. Summer temperatures in the region can exceed 40 degrees Celsius during the day before dropping dramatically at night. Maintaining stable indoor temperatures without electricity should have been nearly impossible. Yet measurements inside surviving adobe chambers showed that temperatures changed far more slowly than outside conditions. The explanation lies partly in thermal mass. Thick mud brick walls absorb heat slowly during the day and release it gradually at night. Some walls inside Rayan exceed 1 meter in thickness, creating natural thermal inertia. But the real sophistication appears in the city's airflow design. Wind catchers and elevated ventilation shafts redirected desert winds downward into living spaces, cooling interiors through pressure differences and passive airflow circulation. Modern climate engineers studying traditional Persian architecture have compared these systems to primitive air conditioning units. Some passive cooling structures in Iran can reduce interior temperatures by more than 15 degrees Celsius without consuming energy. What shocks researchers is that these systems were optimized centuries before modern thermodynamics formally existed as a scientific discipline. The city's water system presents another engineering mystery. Rayan existed in an environment where annual rainfall was extremely limited, yet the settlement supported permanent populations, animals, workshops, and agriculture. Archaeologists believe the fortress relied heavily on qanats, underground water channels developed in ancient Persia thousands of years ago. Qanats are among the most astonishing hydraulic systems ever created. Workers dug long underground tunnels with gradients so precise that water flowed naturally across vast distances without pumps. Some qanat systems stretched for dozens of kilometers beneath desert terrain. Even a minor error in slope could stop water movement entirely or flood the tunnel. Modern civil engineers studying surviving qanats found gradient variations measured in mere centimeters across enormous distances. Accomplishing this without laser surveying equipment or satellite mapping remains deeply difficult to explain. In some regions of Iran, qanat systems continued operating for over 2,000 years. The Persian underground hydraulic network was so effective that UNESCO considers it one of humanity's greatest engineering achievements. But perhaps the most disturbing mystery surrounding Rayan Castle involves the durability of its ancient mud brick materials. Adobe should not survive like this. Ordinary mud structures deteriorate rapidly under moisture, temperature fluctuation, erosion, and vibration. Modern unstabilized mud brick often begins degrading within decades if poorly maintained. Yet Rayan survived centuries of desert winds, seasonal flooding, thermal expansion, and earthquakes. Material scientists studying ancient Persian adobe discovered that these bricks were far more sophisticated than simple dried mud. The composition varied depending on structural purpose. Some samples contain carefully balanced mixtures of clay, sand, straw fibers, lime traces, and organic binding materials. Straw acted similarly to fiber reinforcement in modern composite materials, helping distribute stress and reduce cracking. The density of the adobe layers also appears highly controlled. Builders compacted materials in stages, allowing moisture content to stabilize gradually before additional layers were added. This reduced internal weaknesses caused by uneven drying. Certain surfaces may also have received mineral coatings that increased resistance against water penetration and erosion. Comparisons with modern concrete create an unsettling perspective. Reinforced concrete structures today often require major repair after only 50 to 100 years, especially in harsh climates. Steel reinforcement corrodes, concrete fractures and thermal stress weakens the material over time. Yet parts of Rayan endured for nearly a millennium using earth, straw, and techniques developed without industrial machinery. This has forced some researchers to reconsider assumptions about ancient technological primitiveness. Ancient Persian builders may not have possessed modern chemistry equations, but they understood materials experimentally at an extraordinary level. Their knowledge was accumulated through centuries of observation, failure, climate adaptation, and structural refinement. Rayan's urban design adds another layer to the mystery. The city was engineered defensively with remarkable sophistication. Attackers entering the fortress faced twisting corridors, restricted sightlines, layered gates, elevated firing positions, and maze-like movement patterns designed to fragment enemy formations. Military historians compare aspects of the layout to later defensive concepts found in medieval fortifications across Asia and Europe. Even the positioning of workshops and stables reflected strategic logic. Essential resources were protected deep within the fortress, while outer sectors absorbed initial attacks. The city functioned less like a collection of buildings and more like an integrated survival system. Do you think ancient civilizations understood sustainable engineering better than we do today? Share your thoughts and theories in the comments below. Madinat al-Zahra was once the most dazzling city in Western Europe. Built in the 10th century by the Umayyad Caliph Abd al-Rahman III, near Córdoba in southern Spain, the palace city reportedly shimmered with marble gold, pools of liquid reflections, and halls engineered to manipulate light itself. Then, less than 80 years later, it vanished into ruin. Today, more than 90% of the site still remains buried underground, and archaeologists believe some of its most advanced engineering secrets may still be hidden beneath the hills outside Córdoba. The ruins of Madinat al-Zahra were rediscovered in 1911 by Spanish archaeologist Ricardo Velázquez Bosco after centuries of local legends describing buried palaces beneath the farmland west of Córdoba. Excavations soon uncovered massive reception halls, carved marble columns, hydraulic systems, gardens, and fragments of decorative stonework so refined that many historians compared them to Byzantine imperial architecture. What shocked researchers most was the scale. Historical records suggest the city covered nearly 112 hectares, making it vastly larger than most royal complexes in medieval Europe. Yet only around 10% has been excavated, meaning the overwhelming majority of the city, including possible workshops, underground conduits, and ceremonial sectors, remains unexplored. One of the greatest mysteries surrounding Madinat al-Zahra is how quickly it was constructed. Historical texts claim thousands of workers operated continuously, with as many as 10,000 labourers and over 1,000 animals transporting stone and materials every day. Some chroniclers describe construction progressing at a pace almost unimaginable for the 10th century. Entire palace sectors covered in marble and intricate carvings appeared within decades. Compared to contemporary European cities, the contrast is staggering. During the same period, much of Western Europe was still dominated by relatively small stone fortifications and timber structures. Yet Madinat al-Zahra featured sophisticated urban planning, formal gardens, terraced architecture, advanced water distribution, and monumental ceremonial spaces designed with mathematical precision. Historians often compare Córdoba itself to Constantinople, because both cities possessed paved roads, public baths, libraries, and hydraulic infrastructure at a level rarely seen elsewhere in Europe at the time. The city's water engineering remains one of its most technically mysterious features. Madinat al-Zahra was built on a sloping terrace system along the foothills of the Sierra Morena Mountains. Engineers used gravity-fed hydraulic channels to distribute water across multiple elevations, powering fountains, reflective pools, irrigation systems, and palace baths simultaneously. Archaeologists discovered ceramic pipes, underground conduits, reservoirs, and carefully angled channels with gradients so precise that some vary only slightly over long distances. Maintaining stable water pressure across a terraced complex in a semi-arid climate would have required extraordinary calculations. Modern hydraulic engineers studying the ruins noted that even small deviations in channel slope could have disrupted flow rates entirely. Some researchers compare the engineering challenge to Roman aqueduct systems, yet Madinat al-Zahra integrated these hydraulic mechanisms directly into ceremonial architecture. Water was not merely functional, it became part of the visual illusion of power. But the most fascinating mystery of all may be the city's manipulation of light. Medieval Islamic chronicles described halls where sunlight shimmered across polished marble and metallic surfaces so intensely that visitors believed the rooms were moving. One famous account described a reception hall containing reflective pools and decorative materials that caused light to ripple, like lightning across water. For years, many historians dismissed these descriptions as exaggerated royal propaganda. However, archaeological evidence increasingly suggests the architects of Madinat al-Zahra may have intentionally engineered optical effects through the strategic placement of reflective materials and sunlight angles. The palace complex used enormous quantities of white marble imported from North Africa and other Mediterranean regions. White marble possesses high reflectivity, especially under the intense Andalusian sun. Combined with polished stucco, glazed ceramics, reflective pools, and metallic decorative elements, the architecture may have functioned almost like a massive optical instrument. Some halls appear carefully oriented to maximize natural illumination during specific times of day. Researchers studying solar movement at the site observed that sunlight entering through arches and openings could strike polished surfaces at controlled angles, dramatically amplifying brightness inside ceremonial chambers. This phenomenon resembles principles used in modern architectural lighting design, where reflective materials manipulate perception and emotional response. The so-called Rich Hall, one of the most luxurious structures excavated at the site, demonstrates this especially well. Its carved vegetal patterns, geometric reliefs, and polished surfaces create constantly shifting shadows as sunlight moves throughout the day. The effect is surprisingly dynamic. Instead of static decoration, the hall appears visually alive. Some scholars suggest the architects understood how sunlight interacted with carved depth, reflective surfaces, and water reflections to create psychological impact. Even more intriguing are historical descriptions mentioning pools filled with mercury or highly reflective liquids capable of producing moving flashes of light. While direct archaeological proof remains inconclusive, similar reflective experiments are documented elsewhere in medieval Islamic engineering traditions. If true, Madinat al-Zahra may have employed deliberate sensory manipulation centuries before modern theatrical architecture existed. The precision of the decorative stonework adds another layer to the mystery. Thousands of carved marble fragments recovered from the site display astonishing symmetry and consistency. Floral motifs repeat with near-identical geometry over massive areas. Historians studying the carvings have questioned how artisans working entirely by hand achieved such standardization on such a large scale. Some experts believe the craftsmen used advanced geometric templates and modular design systems far more sophisticated than typically associated with 10th century Europe. Islamic mathematicians during this era were already developing complex geometric theories, including tessellation principles that would later influence Moorish architecture across Spain. Certain repeating patterns at Madinat al-Zahra display mathematical regularity comparable to later Islamic masterpieces such as the Alhambra in Granada. The logistics behind the city remain equally astonishing. Historical accounts mention marble columns arriving from Tunisia, Italy, and even Byzantine territories, transporting thousands of heavy columns across the Mediterranean and then inland to Cordoba would have required immense coordination. Researchers estimate some columns weighed several tons each. Moving them uphill into the terraced palace complex without modern machinery remains difficult to fully reconstruct. Archaeologists are also puzzled by the speed with which the city disappeared. Around the early 11th century, civil war erupted across Al-Andalus during the Fitna period. Madinat al-Zahra was looted, burned, dismantled, and gradually abandoned. Valuable marble and columns were stripped away and reused in later structures throughout the region. Over centuries, the ruins were buried under soil and forgotten almost completely. Yet despite the destruction, modern surveys indicate vast sections remain untouched underground. Ground-penetrating radar has identified buried walls, foundations, and unexplored sectors extending far beyond the excavated areas. Some researchers suspect hidden hydraulic chambers, workshops, or ceremonial structures may still survive beneath the landscape. What do you think is still hidden beneath Madinat al-Zahra lost technology, forgotten engineering knowledge, or something even more mysterious? Share your thoughts in the comments below. On the eastern coast of the Black Sea, only a few kilometers from modern Batumi, the massive stone walls of Gonio Fortress rise from one of the wettest regions in the Caucasus. Archaeologists believe the fortress was originally built during the Roman expansion into Kolchis around the 1st century CE, though deeper excavation layers suggest the site may be significantly older. The first major excavations in the 19th century uncovered Roman pottery, bronze coins, military barracks, drainage channels, and unusually advanced defensive structures. Later, Soviet-era surveys revealed underground tunnels and hidden construction layers beneath the visible Roman walls. Every excavation season seemed to expose something unexpected: older foundations, unexplained engineering solutions, or materials surviving far beyond their expected lifespan. Today, Gonio Fortress remains one of the least understood Roman frontier fortresses ever discovered around the Black Sea. One of the first mysteries surrounding Gonio is its survival itself. The fortress was constructed close to marshy coastal terrain, with heavy rainfall exceeding 2,000 millimeters annually in some years. Ancient fortifications built in such wet environments usually suffer severe foundation collapse after centuries. Yet large portions of Gonio's walls remain standing after nearly 2,000 years. Some wall sections are almost 5 meters thick and consist of massive basalt and limestone blocks fitted together with remarkable precision. Modern structural engineers studying the site found that the foundations distribute pressure unusually evenly, despite the unstable soil underneath. Certain lower layers appear to contain compacted gravel drainage beds, similar to techniques used in advanced Roman hydraulic construction. What makes this puzzling is location. Gonio stood at the far eastern edge of Roman influence, thousands of kilometers from Rome itself. Comparable engineering sophistication is usually associated with major Roman centers like Colosseum or the aqueduct systems of Segovia Aqueduct, not remote military outposts near the Caucasus Mountains. Some researchers argue that Roman engineers may have reused older local engineering knowledge already present in Kolchis long before Roman occupation. During 20th century excavations, archaeologists uncovered one of the most surprising discoveries beneath the fortress: a sophisticated underground drainage network. The channels were constructed with baked clay pipes and carefully angled stone conduits, designed to remove rainwater rapidly from the interior. Measurements showed that some drainage slopes deviated by only a few millimeters over long distances. Even modern gravity-based drainage systems rely on similar precision. The mystery becomes deeper when climate data is considered. The eastern Black Sea coast experiences intense seasonal storms and extremely high humidity. Without efficient water management, a fortress of this scale would slowly collapse from erosion and internal flooding. Yet parts of Gonio's drainage system still function today. Researchers compared the hydraulic planning at Gonio with Roman systems discovered at Pompeii and Ephesus. The similarities were striking, especially in the use of layered sediment traps and runoff control. But unlike Pompeii or Ephesus, Gonio was never considered a major engineering center of the Roman world. That contradiction remains unexplained. Excavations in different sectors of the fortress repeatedly produced evidence that complicated the accepted history of the site. Early digs uncovered Roman military artifacts, including spearheads, armor fragments, and coins from the reign of Emperor Hadrian. Later excavations revealed Byzantine modifications, including reinforced towers and redesigned gate systems. Ottoman-era ceramics and firing positions were found in upper layers. But beneath all of those layers, archaeologists discovered something far more controversial. Deeper stone foundations predating Roman occupation. Carbon dating of organic material trapped within some lower construction layers suggested parts of the site could date centuries earlier than the Roman fortress itself. Some pottery fragments resembled artifacts linked to the ancient Colchian civilization, the same civilization associated with Greek legends surrounding Jason and the Golden Fleece. If these findings are correct, the Romans may not have built Gonio from scratch. Instead, they may have expanded an already ancient stronghold whose original builders remain unknown. Gonio Fortress follows an almost perfectly rectangular layout covering roughly 4.5 hectares. 18 defensive towers were positioned around the perimeter with highly consistent spacing. Military historians studying the fortress noticed something unusual about the tower arrangement. The placement creates overlapping visual and projectile coverage zones, minimizing blind spots around the walls. In practical terms, defenders could attack approaching enemies from multiple angles simultaneously. This principle resembles the interlocking fields of fire concept widely used in early modern European fortress design more than 1,000 years later. The geometry also suggests advanced surveying capability. Creating near-perfect alignment across such a large structure without modern optical equipment would have required extremely accurate measurement methods. Roman surveyors were certainly skilled, but some archaeologists argue that Gonio demonstrates a level of regional military planning rarely seen in frontier fortresses. Another major mystery involves the durability of the fortress materials themselves. Gonio lies close to the Black Sea, where salty air, heavy rain, biological growth, and humidity rapidly destroy exposed stone structures. Many medieval fortifications in similar climates deteriorated severely within only a few centuries. Yet portions of Gonio's original masonry remain remarkably intact after nearly 2 millennia. Material analysis performed on mortar residues found traces of volcanic ash compounds rich in silica and aluminum. Some researchers compared the mixture to Roman pozzolanic concrete, famous for its ability to resist water damage. Roman marine concrete has survived over 2,000 years in Mediterranean harbours because of chemical reactions between volcanic minerals and seawater. The problem is geography. High-quality volcanic pozzolana sources were concentrated mainly around Italy. Scientists still debate how similar material technology may have appeared in a distant Caucasus fortress. Some theories suggest local engineers independently developed similar mixtures using regional volcanic sediments from the Caucasus volcanic belt. Others believe Roman military engineers transported specialized knowledge across the empire more effectively than historians once believed. Modern ground-penetrating radar surveys detected hidden cavities beneath sections of the fortress that remain unexcavated. Some of these underground spaces appear connected through narrow corridors running below the walls. Their exact purpose remains unknown. Possibilities include emergency escape tunnels, military storage chambers, hidden water reservoirs, or secret communication routes. The difficulty is that many sections are partially flooded or structurally unstable. Even with modern imaging technology, archaeologists still cannot fully map the underground network. Several unexplored anomalies continue appearing in geophysical scans, suggesting that significant portions of Gonio may still lie buried beneath centuries of sediment. The fortress is also linked to one of Christianity's oldest traditions. Local belief claims that the tomb of Saint Matthias, one of the 12 apostles of Jesus, lies somewhere within Gonio. No confirmed archaeological evidence has verified the claim, yet the tradition persisted for centuries across Byzantine and Georgian sources. Excavations near the supposed burial area uncovered ancient graves and religious structures, but nothing conclusively tied to Saint Matthias himself. This overlap between military engineering and sacred legend adds another layer to the mystery of the site. What do you think was the greatest mystery hidden inside Gonio Fortress? The advanced engineering, the underground tunnels, or evidence of an older lost civilization beneath the Roman walls? Share your thoughts in the comments below. Perched nearly 400 meters above the Pontine Plain in central Italy, the ruined city of Norba contains one of the most disturbing engineering mysteries of the ancient Mediterranean. Massive stone walls, some rising more than 13 meters high, still cling to the mountainside after over 2,000 years of earthquakes, wars and erosion. The stones are not rectangular like typical Roman construction. Instead, they are enormous irregular polygons fitted together with such precision that even modern engineers struggle to explain how Iron Age builders achieved it. No mortar binds them. No metal clamps hold them in place. Yet the walls remain standing while entire civilizations around them disappeared. The greatest mystery is not simply who built Norba, but where the knowledge behind its impossible masonry truly came from. The ruins lie near the modern town of Norma in the Lazio region of Italy. Ancient historians briefly mention Norba as a Latin colony established around the 4th century BCE, but for centuries the site remained largely abandoned and overgrown. Travelers during the Renaissance described gigantic cyclopean walls, believing they must have been built by mythical giants because ordinary humans could not possibly move stones of such scale. Systematic archaeological studies began in the 19th century, revealing an entire fortified city spread across more than 30 hectares. Excavations uncovered gates, roads, cisterns, temples, and defensive structures, but the walls themselves became the center of fascination. They did not resemble standard Roman military architecture at all. Instead, they appeared far older and technologically disconnected from the masonry traditions that later dominated the Roman world. At first glance, Norba's walls look chaotic, almost primitive, but closer inspection reveals astonishing geometric control. The stones vary wildly in size and shape, yet each block interlocks perfectly with the next. Some individual stones weigh several tons. The joints between them are so precise that in many places a thin blade cannot fit into the gaps. Modern stonemasons have noted that creating such polygonal interfaces is often more difficult than producing straight rectangular blocks, because every angle must match multiple neighbouring surfaces simultaneously. The complexity increases exponentially with each additional side. This raises the first major mystery. How were these stones measured and shaped with such precision using the tools available around the 4th century BCE? Iron tools from the period were relatively soft compared to modern steel. bronze tools would have struggled even more against dense limestone. Experimental archaeology has shown that reproducing a single high-precision polygonal block using ancient methods can require weeks of labour. Yet Norba's walls stretch for roughly 2.5 kilometres across uneven mountain terrain. The sheer labour investment appears almost irrational for a settlement of this size. Even more puzzling is the transportation problem. Some stones were quarried locally, but moving multi-ton blocks uphill across steep rocky slopes would have required immense coordination. There is little archaeological evidence for advanced lifting machinery comparable to later Roman cranes. No inscriptions describe the process. No surviving blueprints exist. The builders left behind the result, but almost none of the method. The second mystery involves structural resilience. Italy is one of the most seismically active regions in Europe. Over the last 2,000 years, the Apennine fault system has produced repeated destructive earthquakes. Conventional rigid masonry often collapses under lateral seismic stress because cracks propagate along straight joints. Norba's polygonal walls behave differently. Their irregular interlocking geometry distributes forces across multiple angles, preventing catastrophic fracture lines from forming easily. Modern structural engineers studying polygonal masonry have compared it to three-dimensional mechanical locking systems. In some ways, the design behaves similarly to anti-seismic principles used in modern earthquake-resistant architecture. Instead of resisting motion through rigidity alone, the stones absorb and redistribute energy through countless contact surfaces. This may explain why sections of Norba's walls still survive, while later Roman constructions nearby deteriorated more severely. What makes this extraordinary is the possibility that ancient builders understood seismic stability empirically centuries before formal engineering theory existed. Similar observations have been made at sites like Sacsayhuaman, where gigantic polygonal walls also survived major earthquakes that destroyed Spanish colonial buildings erected above them. The resemblance between these distant cultures has fueled endless debate. Some researchers see convergent engineering evolution. Others believe polygonal masonry represents a forgotten high-efficiency construction tradition once more widespread across the ancient world. Norba's defensive design adds another layer of sophistication. The city occupies a naturally fortified limestone plateau, overlooking critical trade routes and fertile plains. Approaching armies would have faced steep ascents while remaining exposed to defenders above. The gates themselves reveal strategic intelligence far beyond simple wall building. Entrances were angled in ways that forced attackers to expose their unshielded side during entry. Narrow passages restricted troop movement. Observation points allowed defenders to monitor vast distances across the landscape. These features resemble principles later refined in medieval fortification systems, yet Norba predates many of them by centuries. Historians often describe Roman military engineering as highly systematic and standardized, but Norba feels different. Its design appears adapted organically to terrain, geology, and defensive geometry in ways that seem unusually advanced for its era. Still, the greatest mystery surrounding Norba is the origin of polygonal masonry itself. This style appears at several ancient Italian sites including Alatri Acropolis, Segni, Ferentino, and Circe. In some locations, the masonry reaches even greater precision than at Norba. The problem is that historians still cannot agree on who first developed the technique. Traditional explanations attribute the walls to Italic peoples such as the Volsci or early Latins before Roman expansion. However, the engineering sophistication has led some scholars to argue that the method may have originated much earlier. 19th century archaeologists coined the term Cyclopean masonry because the stones appeared too massive for ordinary ancient builders. While the giant mythology is symbolic, the underlying question remains unresolved. Why did this incredibly durable and effective technique largely disappear later in Roman architecture? The Romans became masters of arches, concrete, and standardized rectangular stonework. Yet they rarely reproduced polygonal masonry at the same scale and precision. This discontinuity is deeply unsettling. Normally, technologies evolve toward greater efficiency and refinement, but polygonal masonry seems to vanish despite its remarkable durability. Some researchers suggest the method demanded too much labor to remain economically viable once Roman concrete emerged. Others believe the specialized craftsmanship required generations of transmitted knowledge that were eventually lost during political and cultural transitions. There are also unresolved chronological debates. Certain sections of polygonal walls in Italy appear weathered to degrees suggesting far greater antiquity than official dating proposes. Unlike Roman concrete, stone walls are notoriously difficult to date directly. Archaeologists rely mainly on surrounding artifacts and settlement layers. This creates uncertainty. Were some polygonal foundations already ancient before the Romans arrived? Did later civilizations simply inherit and reuse them? The mystery deepens when comparing Norba to other megalithic cultures worldwide. At Ollantaytambo and Sacsayhuaman, builders achieved similarly tight stone fitting with enormous irregular blocks. In Greece, parts of Mycenaean fortifications also use massive polygonal techniques. None of these civilizations had contact across oceans, yet the engineering logic appears strangely parallel. Human ingenuity alone may explain it, but the recurrence of the same difficult, labor-intensive method across unrelated cultures continues to fascinate researchers. What do you think the builders of Norba truly understood about stone engineering that was later lost to history? Share your thoughts in the comments below. Hasanlu Tepe sits near the southern edge of Lake Urmia in northwestern Iran, where archaeologists uncovered one of the most violently preserved ancient cities ever found. Around 800 BCE, the entire settlement was destroyed in a catastrophic fire so sudden that people died where they stood, leaving behind frozen moments of panic buried beneath collapsed mudbrick and burning timber. Nearly 3,000 years later, Hasanlu still contains mysteries that modern archaeology and engineering cannot fully explain. The site was first excavated systematically in the 1950s by Robert H. Dyson Jr. from the University of Pennsylvania. Beneath multiple occupation layers, archaeologists uncovered a major Iron Age city destroyed in a single event. Entire rooms remained sealed under debris. Human skeletons were discovered trapped in stairways, alleyways, and collapsed halls. Unlike many ancient ruins slowly abandoned over centuries, Hasanlu looked as if time had stopped in one night. The destruction layer itself became one of the greatest archaeological time capsules of the ancient Near East. The deeper researchers studied Hasanlu, the stranger the site became. The fire that destroyed Hasanlu was not an ordinary urban fire. Evidence from burned timber, vitrified mud surfaces, and collapsed architecture suggests temperatures may have exceeded 800 degrees Celsius in some sections, comparable to temperatures used in primitive industrial firing processes. Mud brick structures normally disintegrate rapidly when exposed to centuries of moisture and freeze-thaw cycles. Yet many Hasanlu walls survived in recognizable form for nearly 3 millennia. Archaeologists believe the destruction itself may have accidentally preserved the city, because the intense heat likely hardened portions of the mud brick in a process similar to low-temperature ceramic firing. This phenomenon has been compared to partially fired mud brick structures found at sites in Mesopotamia, but Hasanlu's preservation is unusually extensive. Some walls collapsed inward while still structurally semi-rigid, trapping entire rooms beneath sealed debris layers. Organic materials, including wooden beams and food remains, were preserved in carbonized form because oxygen levels rapidly dropped beneath the rubble. Researchers still debate how the fire spread so quickly through such a large settlement. Some believe attackers deliberately targeted roof supports and storage zones to create chain reaction collapses, while others suspect the architecture itself unintentionally amplified the destruction. Large, timber-reinforced mud brick buildings may have functioned like enormous furnaces once ignited. The most famous object ever discovered at Hasanlu is the Hasanlu gold bowl, found clutched by a man who died while apparently trying to escape the burning city. Weighing nearly 1 kilogram and made from high-purity gold, the bowl is covered with intricate mythological scenes hammered into the metal with astonishing precision. What makes the artifact extraordinary is not simply its beauty, but the technical sophistication required to manufacture it around the 9th century BCE. The bowl was likely produced using repousse and chasing techniques, where craftsmen hammered designs from the reverse side and refined details from the front. However, metallurgical analysis suggests an unusually advanced level of control over gold thickness and stress distribution across the surface. In many ancient repousse works, repeated hammering creates weak points, uneven surfaces, or microfractures, yet the Hasanlu bowl displays remarkably consistent structural integrity despite its dense relief imagery. Some sections contain extremely fine raised details only millimeters deep, requiring controlled force distribution across thin gold sheets without tearing the metal. Even modern restorers note how difficult it would be to reproduce the bowl accurately using reconstructed Iron Age tools alone. The symmetry of the imagery also raises questions, because several circular compositions maintain highly balanced spacing, despite being executed entirely by hand. Without modern calipers, precision grids, or optical measuring systems, maintaining proportional continuity around a curved golden surface would have required extraordinary planning. Comparisons with the Syrian and Eurasian metalwork from the same period show similarities in iconography, yet the Hasanlu bowl often appears technically more refined in depth transitions and compositional density. Some researchers believe the craftsman may have inherited older metallurgical traditions now completely lost. Even more mysterious is the gold itself. Trace element analysis suggests the metal may have originated from multiple ore sources, implying long-distance trade networks or sophisticated recycling practices. At a time when transportation across the Zagros region was extremely difficult, Hasanlu somehow had access to elite materials and artisans capable of working them at near masterpiece level. To this day, archaeologists still cannot fully explain how craftsmen prevented deformation during deep repousse work, how they controlled heating and annealing cycles without modern temperature measurement, how they achieved such uniform thickness across large hammered sections, or how such advanced artistry emerged in what was supposedly a peripheral highland settlement rather than an imperial capital. The bowl feels less like an isolated artwork and more like surviving evidence of a technical tradition mostly erased from history. Hasanlu stood in a tectonically unstable region where earthquakes were common, yet several major structures show evidence of engineering strategies that appear unusually resilient for the Iron Age. Many walls were constructed with thick mud brick exteriors reinforced internally by timber frameworks, a combination resembling anti-seismic techniques later seen in Persian and even some medieval Middle Eastern architecture. Wood absorbs and redistributes vibrational energy more flexibly than solid masonry alone. Some collapsed walls bent and folded instead of exploding outward into fragmentation. Structural engineers studying ancient earthquake damage patterns Note that this behaviour suggests partial energy dissipation inside the wall cores. At other Near Eastern sites from the same era, pure mud brick construction often failed catastrophically during seismic activity, but Hasanlu's hybrid structural methods may have significantly improved survival rates during smaller tremors. The mystery is whether these builders truly understood seismic behaviour experimentally, or whether the design evolved accidentally through generations of reconstruction after repeated earthquakes. Either explanation implies a level of architectural adaptation more sophisticated than traditionally assumed for Iron Age settlements. Standard mud brick architecture deteriorates relatively quickly in regions exposed to seasonal moisture and winter freezing. Northwestern Iran experiences harsh winters, temperature variation, and periodic precipitation, conditions normally destructive to unfired earthen structures. Yet Hasanlu's destruction layer remained remarkably stable. Material analysis revealed unusually dense mud brick mixtures containing fine mineral inclusions, organic fibres, and carefully sorted clay compositions. Some samples exhibit compressive strengths noticeably higher than standard Near Eastern mud brick from comparable periods. Researchers suspect builders may have intentionally added volcanic ash, silica-rich sediments, or plant fibres to reduce cracking during drying. Similar stabilizing principles appear later in Persian Saruj mortar and Roman pozzolanic concrete, though Hasanlu predates many famous examples of advanced ancient composite materials. The consistency of the mixtures suggests standardized production methods rather than random local improvisation, implying skilled material specialists existed within the settlement. Hasanlu was not Babylon or Nineveh, yet the number of elite artifacts discovered there suggests access to wealth, trade, and skilled labour far beyond what archaeologists expected from a regional settlement. Imported materials, luxury goods, weapons, and complex storage systems indicate Hasanlu held a strategic position between Mesopotamia, Anatolia, and the Iranian plateau. Large storage rooms and administrative ceilings point to organised food management and bureaucratic control over trade and resources. What makes this difficult to explain is that Hasanlu thrived in a mountainous frontier region, surrounded by constant warfare between Assyria, Urartu, and local powers. Despite that instability, the city maintained a level of economic organisation and technical sophistication far beyond what its size would normally suggest. Who do you think truly destroyed Hasanlu? And how much ancient knowledge may have vanished in that single night of fire? Share your thoughts in the comments below. Northern Israel's Jezreel Valley holds one of the most mysterious archaeological sites ever discovered, Tel Megiddo. Early excavations began in the early 20th century under German archaeologist Gottlieb Schumacher, but later digs by the Oriental Institute of the University of Chicago revealed something extraordinary. Megiddo was built, destroyed, and rebuilt more than 20 times across nearly 5,000 years, each civilization constructed directly on top of the ruins of the previous one, creating an artificial mound nearly 60 feet high. Archaeologists uncovered layers dating from the early Bronze Age to the Assyrian Empire, turning Megiddo into one of the most complex archaeological timelines ever discovered in the ancient world. But the deeper researchers excavated, the stranger the site became. Megiddo was not simply a city. It appeared to be a military engineering hub operating at a technological level that many historians believe should not have existed in the ancient Levant during the 2nd and 1st millennia BCE. Its scale, infrastructure, underground systems, and logistical organization continue to challenge modern understanding of early urban engineering. The greatest mystery beneath Megiddo lies underground. At some point around the 9th century BCE, engineers carved an enormous water access system directly through solid limestone bedrock. The project included a vertical shaft approximately 35 meters deep, connected to a tunnel more than 70 meters long leading toward a hidden spring outside the city walls. The purpose was revolutionary for its time. Instead of forcing citizens to leave the city during sieges to collect water, Megiddo's inhabitants created a concealed underground route, allowing secure access even while enemies surrounded the fortress. The engineering problem, however, is what confuses modern researchers. Ancient workers excavated downward through hard rock with primitive iron and bronze tools, then precisely redirected excavation horizontally underground with remarkably small navigational error. Without modern surveying equipment, lasers, explosives, ventilation systems, or electric lighting, the builders somehow maintained directional accuracy deep below the surface. Compared to other ancient water systems such as Hezekiah's tunnel in Jerusalem or the Qanat systems of Persia, Megiddo's construction remains unusually ambitious for its period. Engineers estimate that removing thousands of tons of limestone manually would have required enormous labor coordination and long-term planning. Even today, recreating such excavation entirely by hand would be a major logistical operation. Megiddo controlled the Via Maris, the ancient trade route linking Egypt with Mesopotamia. Whoever controlled Megiddo controlled one of the most important economic arteries in the ancient Near East. Because of this, the city evolved into a massive fortified military center. Its walls were multi-layered. Defensive sectors were arranged strategically. Storage facilities, administrative compounds, barracks and gates were integrated into a sophisticated urban defense layout rarely seen in cities of comparable age. The most controversial structure is the famous six-chambered gate. Constructed from enormous stone blocks fitted with surprising precision, the gate forced invaders through narrow defensive corridors while exposing them to attack from multiple sides. Similar gate systems appear at Hazor and Giza, leading some archaeologists to argue they were part of a centralized construction program during the reign of King Solomon around the 10th century BCE. Others fiercely disagree. Carbon dating and ceramic analysis from later excavations suggest some structures may actually belong to the Omrida dynasty nearly a century later. This debate is critical because it changes the entire timeline of state formation in ancient Israel. If Megiddo's monumental structures truly date to Solomon's era, then the kingdom possessed engineering capabilities and centralized political organization far more advanced than previously believed. One of the most debated discoveries at Megiddo involves a series of long stone buildings traditionally interpreted as horse stables. The structures include rows of stone pillars, tethering holes, feeding troughs, drainage systems, and enough capacity to hold hundreds of horses. Some reconstructions estimate space for nearly 500 war horses. If correct, Megiddo may have functioned as one of the largest chariot war centers in the ancient Near East. This would place it alongside military powers such as Egypt, Assyria, and the Hittite Empire, all of which relied heavily on horse-drawn warfare. But the mystery remains unresolved. Some archaeologists argue these buildings were not stables at all. They may have been warehouses, military storage halls, or barracks repurposed later for animals. Others believe evidence for horse occupation is strong due to wear patterns, organic residues, and structural layout. The argument reveals something deeper about Megiddo. The city appears to have operated on a scale far beyond what many scholars once thought possible for Iron Age kingdoms in the Levant. Maintaining hundreds of horses would require massive grain production, water distribution, veterinary knowledge, stable management, and transportation networks. In practical terms, it implies an organized logistical machine approaching early imperial standards. Another unexplained aspect of Megiddo is the durability of its construction materials. Sections of walls, floors, and compacted surfaces survived thousands of years despite earthquakes, wars, erosion, and extreme temperature fluctuations. Some floor layers remain extraordinarily dense and resistant, even without modern cement technology. Researchers studying ancient Near Eastern construction discovered that many builders used carefully engineered mixtures of lime, ash, crushed stone and compacted sediment to create durable surfaces with impressive load-bearing capacity. Yet certain material compositions at Megiddo still remain poorly understood. In some locations, mud brick structures survived far longer than expected in seasonal climates capable of rapidly destroying untreated earth architecture. Archaeologists suspect builders possessed sophisticated empirical knowledge of drainage, moisture control, and soil stabilization. The mystery resembles other ancient engineering puzzles such as Roman marine concrete, whose chemical self-strengthening reactions were only recently understood through microscopic analysis. Megiddo may represent another lost branch of ancient material science. Few cities in history experienced as much destruction as Megiddo. Egyptians, Canaanites, Israelites, Assyrians, and later empires fought repeatedly over the region. Archaeological layers show evidence of fires, collapses, warfare, and violent reconstruction cycles across centuries. Yet every time the city was destroyed, another civilization rebuilt directly on top of the ruins. This process required extraordinary labor organization. To reconstruct massive fortifications, underground systems, gates, storage complexes, and administrative centers repeatedly over centuries implies access to large workforces, quarrying operations, transportation infrastructure, and centralized planning authorities. Modern scholars often underestimate how difficult such rebuilding would have been without industrial machinery. Moving multi-ton stones manually, excavating defensive systems by hand, and supplying construction materials continuously would demand social coordination, approaching that of early states or proto-empires. Megiddo forces historians to reconsider how advanced Bronze and Iron Age administrative systems may actually have been. What makes Megiddo even more mysterious is that the site continuously changes historical interpretation itself. Every new excavation season produces discoveries that challenge earlier conclusions. Carbon dating results contradict old chronologies, pottery sequences shift timelines. Architectural phases are constantly reassessed. Few archaeological sites generate as much academic conflict. Some researchers see Megiddo as proof of a highly centralized biblical kingdom, with monumental architecture and advanced state engineering. Others argue the city's greater structures belong to later political powers, and that earlier kingdoms were smaller and less organized. In other words, Megiddo is not only a mystery of ancient engineering, it is a mystery about how modern civilization reconstructs the past itself. Do you think Tel Megiddo proves that ancient civilizations were far more advanced than we've been taught? Or are modern researchers still missing part of the bigger picture? Share your thoughts in the comments below. Albalid Archaeological Park stands on the southern coast of Oman, where desert cliffs meet the Arabian Sea. Today the ruins look silent and fragile, but nearly 1,000 years ago this was one of the richest ports on Earth. Ships crossed thousands of kilometers of dangerous ocean to reach it for a substance once valued almost like gold: frankincense. What archaeologists discovered beneath the sand was not just a lost trading city, but evidence of engineering systems, climate adaptation, and preservation technologies that still remain partially unexplained. The ruins of Albalid were systematically investigated during the 20th century after scholars connected the site to medieval Arab records describing the prosperous port of Zafar. Excavations uncovered fortified walls, mosques, storage complexes, harbour structures, drainage systems, and imported ceramics from China, Persia, East Africa, and India. Radiocarbon analysis and ceramic studies suggest the city flourished between the 8th and 16th centuries CE during the peak of the Indian Ocean trade network. But the deeper archaeologists excavated, the stranger the site became. This is the greatest technological mystery surrounding Albalid. Frankincense is not an ordinary trade good. It is a resin harvested from boswellia trees growing in harsh environments across southern Oman and parts of Yemen. In the ancient world, it was burned in temples, used in embalming rituals, medicine, perfume production, and elite ceremonies. Roman historians described Arabian frankincense as one of the most valuable substances entering the Mediterranean world. But frankincense presents a major problem. The resin rapidly degrades when exposed to excessive humidity, unstable temperatures, salt air, or microbial contamination. Long-distance maritime transport across the Arabian Sea should have damaged massive quantities of cargo, yet historical records repeatedly describe Omani frankincense arriving in remarkably high condition, even after voyages lasting weeks or months. At Albalid, archaeologists discovered evidence suggesting the city may have possessed advanced passive preservation systems far beyond what historians once assumed medieval Arabian ports could achieve. Some storage buildings contain unusually thick walls, narrow ventilation corridors, airflow-oriented layouts, and chambers positioned according to prevailing monsoon winds. Researchers noticed that certain warehouses appear designed to stabilize internal temperatures naturally, resembling principles seen in Persian wind catchers, Roman passive cooling systems, and even modern climate-responsive architecture. In some areas, wall thickness changes depending on exposure to sunlight and seasonal wind direction, suggesting the builders understood thermal transfer with surprising sophistication. Modern studies on traditional Arabian construction show that thick lime-plastered walls can reduce interior temperature fluctuations by several degrees Celsius. Combined with controlled airflow, this could have dramatically slowed resin degradation. The mystery becomes even more significant when considering scale. Historical estimates suggest tons of frankincense move through southern Arabia annually. Ancient Roman sources claimed the incense trade generated enormous state revenues, while Pliny the Elder described caravans protected almost like military operations. Albalid may have functioned as one of the critical maritime gateways connecting this trade to India and East Africa. Yet archaeologists still do not fully understand how such enormous quantities were preserved consistently in a humid coastal environment. Some researchers suspect the use of mineral-based sealing compounds, organic antifungal coatings, specialized ceramic storage containers, or controlled airflow engineering now lost to history. The site increasingly resembles a forgotten industrial center rather than a simple medieval port. One of the strangest aspects of Albalid is that the city survived for centuries in an environment that should have been extremely destructive to urban infrastructure. The Dhofar coast experiences salt-heavy air, seasonal monsoon moisture, intense heat, and shifting groundwater conditions. Most coastal settlements exposed to these conditions suffer rapid structural decay. Salt penetrates stone and brick, expands during crystallization, and gradually destroys walls from within. Even modern concrete suffers heavily under such conditions. Yet parts of Albalid remained structurally stable for hundreds of years. Archaeologists discovered drainage channels and water control systems, suggesting careful management of groundwater and seasonal flooding. Some foundations appear elevated or layered in ways that reduce salt intrusion. This has led to comparisons with Roman marine engineering, Nabatean water systems at Petra, and Persian Saruj waterproof mortar technologies. Certain surviving plaster fragments contain unusually durable lime mixtures that resisted erosion far longer than expected. Researchers believe local builders may have combined shell-derived lime, ash, and mineral aggregates to create materials adapted specifically for coastal humidity. The engineering logic behind the city appears highly specialized for climate survival. Albalid became wealthy because it stood at the center of one of the most dangerous maritime trade systems of the ancient and medieval world. The Arabian Sea is heavily influenced by monsoon cycles. Winds reverse seasonally, currents shift dramatically, and storms can become catastrophic. Navigating these waters without advanced instruments should have been extraordinarily risky. Yet merchants operating from southern Oman maintained trade connections extending west toward East Africa, east toward India, and north toward the Persian Gulf. Excavations uncovered imported ceramics from China's Song and Ming periods, showing that Albalid participated in trade networks spanning thousands of kilometers. The mystery is not simply that these voyages existed, the mystery is their consistency. To maintain profitable trade over centuries, navigators needed accurate understanding of monsoon timing, stellar navigation, ocean currents, seasonal humidity, and cargo preservation. Arab navigators later became famous for celestial navigation techniques using stars and angular measurements, but some historians believe this knowledge may have originated from much older maritime traditions developed in ports like Albalid. This raises a larger question: how much ancient oceanographic knowledge has been lost? The architecture of Albalid appears designed not for beauty alone, but survival. Many structures use compact street layouts, controlled airflow corridors, strategic wall orientation, and materials optimized for thermal regulation. This resembles techniques later seen across Islamic desert architecture. Some researchers argue that cities like Albalid mastered passive cooling centuries before industrial ventilation existed. Certain building remains indicate an understanding of solar exposure, shadow management, heat absorption, and nighttime cooling cycles. In modern sustainability research, passive cooling systems inspired by Middle Eastern architecture can reduce indoor temperatures by 5 to 10 degrees Celsius without mechanical air conditioning. That makes Albalid remarkable because its builders achieved environmental adaptation using only stone, lime, airflow, geometry, and local materials. No electricity, no machines, and no modern engineering software existed, yet the city functioned for centuries in one of the harshest coastal climates in Arabia. Perhaps the greatest unanswered question is why such a wealthy city disappeared. Historical evidence suggests Albalid declined between the 15th and 16th centuries. Trade routes shifted, political instability increased, and some evidence points toward destructive conflict. But archaeology reveals a more complicated story. Certain areas show burning damage, others appear gradually abandoned, and some sections were buried unusually quickly by sand accumulation. Researchers proposed multiple explanations, including regional warfare, economic collapse, climate change, disease, or changing maritime routes after the rise of Portuguese naval power. Yet no single theory explains everything. A city that once controlled one of the world's most valuable trade commodities simply faded into silence. And beneath the ruins remain signs of engineering knowledge that still has not been fully reconstructed. Do you think Albalid was simply an ancient trading city, or the remains of a forgotten technological civilization that understood climate preservation and maritime engineering far better than we realize today? Share your thoughts in the comments below. Northeastern Azerbaijan holds the ruins of Chira Gala, a fortress standing more than 1,200 meters above sea level, surrounded by cliffs, violent winds, and steep volcanic stone ridges. From a distance, it looks impossible. A massive military complex built on terrain where even modern construction equipment would struggle to operate. Yet for nearly 15 centuries, its walls resisted earthquakes, erosion, invasions, and extreme weather. Even stranger historians believe this isolated fortress may once have been part of an ancient long-distance communication network, capable of transmitting warning signals across the Caucasus Mountains long before modern telecommunications existed. Today, many archaeologists consider Chira Gala one of the least understood military engineering sites of the early medieval world. Although local communities had known about the ruins for centuries, systematic archaeological surveys only intensified during the 20th century under Soviet-era Caucasus expeditions. Researchers quickly realized the fortress was far larger and more sophisticated than previously assumed. Built during the period of the Sassanid Empire, likely between the 5th and 6th centuries AD, Chira Gala occupied a strategic position overlooking routes connecting the Caspian coast to the northern Caucasus frontier. Excavations uncovered defensive walls, towers, reservoirs, stone foundations, and evidence of prolonged military occupation. But the deeper archaeologists investigated, the more puzzling the site became. The fortress was not simply placed on the mountain. It was engineered into the mountain itself. The most controversial theory surrounding Chira Gala involves its possible use as part of an ancient optical communication network. The name Chirag Gala is often translated as Fortress of Light or Lamp Fortress. Historians believe this may not be symbolic. Instead, it could describe the actual function of the structure. From the highest towers, observers can see enormous stretches of surrounding terrain, including distant mountain corridors and lowland approaches near the Caspian basin. Modern topographic analysis suggests visibility lines from Chira Gala overlap with several other ancient fortified positions scattered across the Caucasus. This has led some researchers to propose that the Sassanids created a chain of mountaintop signal stations capable of relaying warnings across hundreds of kilometers. The concept itself sounds surprisingly advanced for the 6th century. Yet historically, long-distance visual signaling systems did exist in ancient civilizations. The Byzantine Empire later used beacon chains across Anatolia. Ancient China developed smoke signal towers along frontier defenses. Even the Greeks experimented with coded torch systems described by Polybius more than 2,000 years ago. But Chira Gala presents unusual technical challenges. The Caucasus Mountains are notorious for heavy fog, sudden storms, and unstable visibility conditions. Maintaining reliable communication under such conditions would require extremely precise positioning of observation towers. Researchers using satellite mapping discovered that several fortress locations appear intentionally placed within direct visual range of one another despite the difficult terrain. This suggests the builders understood line-of-sight geometry at a sophisticated level. Some historians speculate that signal fires may have been amplified using polished metal reflectors or shielded beacon chambers designed to increase visibility at long distances. Others believe coded smoke pulses or sequential torch patterns may have been used to transmit specific military warnings. No surviving written manual explaining the system has ever been found. What makes the mystery even more fascinating is the speed such a network could theoretically achieve. A mounted messenger traveling through mountain terrain might require days to deliver military information. But a relay system using sequential fire signals could potentially transmit warnings across frontier regions within hours or even minutes under ideal conditions. For an empire constantly threatened by northern invasions, such speed would have been revolutionary. If the theory is correct, Chira Gala may represent one of the most advanced early warning systems of the ancient Caucasus world. The fortress itself raises enormous engineering questions. Transporting construction materials to such altitude would have been extraordinarily difficult. Many surviving stone blocks weigh several hundred kilograms. Some wall sections sit directly beside vertical cliff faces, where there is barely enough space for modern hikers to stand safely, yet the masonry remains remarkably stable. Unlike conventional fortifications built on flat ground, the walls of Chira Gala follow the mountain's natural geometry. Instead of forcing straight defensive lines, the builders adapted every section to the rock beneath it. Angles shift constantly, foundations curve around cliffs. Defensive corridors merge into natural stone barriers. This adaptive construction technique resembles certain high-altitude fortresses found in Iran and parts of the Byzantine frontier, But Chira Gala's terrain is arguably even more extreme. Engineers studying earthquake-resistant ancient architecture have noted another unusual feature. Many sections lean slightly inward rather than standing perfectly vertical. Modern structural simulations show this inward angle may help distribute seismic stress more effectively during earthquakes. Considering the Caucasus region experiences frequent tectonic activity, this may not have been accidental. The builders appear to have understood principles of load distribution and geological stability centuries before formal structural engineering existed. One of the greatest mysteries surrounding Chira Gala is survival. How could a fortress on such a barren mountain sustain soldiers for long periods? Archaeologists discovered reservoirs and water storage systems carved directly into the rock, but rainfall alone may not have been sufficient for a permanent garrison. This has triggered theories that the fortress used advanced water harvesting techniques or hidden spring collection systems inside the mountain itself. Some cistern interiors contain traces of unusual waterproof coatings. Similar ancient hydraulic coatings have been identified in Sassanid and Roman engineering projects, often involving combinations of lime, ash, mineral dust, and organic additives. What makes Chira Gala remarkable is the durability of these systems under harsh mountain conditions. Even after more than 1,000 years of freeze-thaw cycles, parts of the water infrastructure remain identifiable. Some researchers compare the mystery to the durability of Roman concrete, which continues to puzzle materials scientists today because of its unexpected resistance to chemical erosion. If Chira Gala possessed an efficient mountain water management system, it would explain how the fortress could operate during prolonged sieges despite its isolated location. The location of Chira Gala may also have served psychological purposes. Any invading force approaching from below would see massive stone walls emerging directly from the mountain ridges. From certain angles, the fortress appears almost fused with the landscape itself. Military historians believe this visual dominance may have been intentional. Ancient defensive architecture often relied not only on physical barriers but also intimidation. At Chira Gala, attackers face steep ascents under constant exposure from elevated defenders. Even small defending forces could potentially control narrow access routes with devastating efficiency. Some surviving tower positions suggest overlapping observation zones capable of monitoring multiple valleys simultaneously. This resembles later medieval kill zone strategies, yet Chira Gala predates many of those systems by centuries. Its builders may have created one of the earliest examples of terrain-integrated mountain warfare architecture in the Caucasus region. Modern drone surveys indicate the visible ruins may represent only a fraction of the original system. Satellite imaging has revealed traces of collapsed walls, terraces, and possible lower defensive positions extending down the mountainside. Erosion and landslides may have buried major sections of the complex beneath rock and sediment. Some archaeologists suspect Chira Gala was not an isolated fortress at all, but part of a vast defensive chain protecting the northern frontier of the Sassanid Empire against nomadic incursions from the Eurasian steppes. This theory aligns with other regional fortifications, including massive defensive systems near Derbent, sometimes called the Caspian Gates. Together, these structures may have formed one of the largest coordinated frontier defense systems of the ancient world. Yet large portions remain unexplored because of dangerous terrain and limited excavation access. What do you think Chira Gala truly was? Just a mountain fortress, or part of a forgotten ancient communication network far ahead of its time? Share your thoughts in the comments below. In central Anatolia, nearly 100 kilometers southwest of modern Ankara, a massive artificial hill rises above the dry plains of Turkey. Beneath it lies Gordian, the ancient capital of Phrygia and the legendary city of King Midas. But the real mystery of Gordian is not gold, it is engineering. Hidden under layers of burned cities, collapsed walls, and sealed burial mounds are structures that have survived for almost 3,000 years with a level of material preservation and architectural stability that still confuses archaeologists today. Although travellers had noticed the enormous mound for centuries, systematic excavation only began in the 1950s under the University of Pennsylvania Museum led by Rodney Young. What archaeologists uncovered was shocking. Gordian was not a single city buried in time. It was a layered megastructure of civilizations stacked on top of one another, with some occupation phases dating back to roughly 2500 BCE. The central citadel mound alone rose over 50 meters high and covered nearly 13 hectares, making it one of the largest artificial settlement mounds in the ancient Near East. The deeper researchers excavated, the stranger the sight became. Entire districts appeared carefully rebuilt after catastrophic destruction events. Massive wooden chambers remained partially intact after nearly 3 millennia underground. Some walls still showed evidence of advanced reinforcement methods. Instead of resembling a primitive Iron Age settlement, Gordian increasingly looked like a city engineered to survive disaster. Most ancient cities expanded naturally over time. Gordian appears different. Archaeologists discovered evidence suggesting the mound itself was deliberately stabilized, using alternating layers of compacted earth, stone debris, clay, and construction fill. These layers likely distributed weight and reduced structural instability across the settlement. This matters because central Anatolia sits within a tectonically active region. Modern engineers use layered soil stabilization techniques to reduce vibration and settlement damage, especially in earthquake-prone areas. Yet evidence from Gordian suggests builders may have understood similar structural principles almost 3,000 years ago. The city's fortification walls also raise questions. Some defensive walls exceeded 8 meters in height and used carefully fitted limestone blocks combined with timber reinforcements embedded within the masonry. Similar hybrid systems later appeared in Greek and Roman seismic construction, but Gordian predates many of those examples by centuries. Researchers found signs that timber was intentionally inserted into walls not simply for support, but to absorb stress and distribute movement. In modern structural engineering, flexible reinforcement is essential for resisting vibration and thermal expansion. Whether the Phrygians understood the physics behind it remains unknown, but the practical result was remarkably effective. The greatest mystery of Gordian lies inside Tumulus MM, a colossal burial mound approximately 53 meters high and over 300 meters in diameter. It is one of the largest burial mounds ever discovered in Anatolia and is widely associated with the family of King Midas, likely his father Gordius. Inside the mound, archaeologists uncovered something almost impossible: an enormous wooden burial chamber still standing after nearly 2,700 years. Wood is one of the least durable ancient building materials. Under normal conditions, moisture, bacteria, fungi, and insects destroy timber rapidly. Yet many beams inside Tumulus MM remained astonishingly well preserved. Some retained tool marks, others still held their structural alignment despite supporting immense pressure from thousands of tons of earth above them. The chamber itself measured roughly 5 by 6 meters and was constructed using massive cedar and juniper beams precisely interlocked without relying heavily on metal fasteners. Some timbers exceeded 25 centimeters in thickness. The engineering precision was extraordinary. Every beam distributed weight in a way that prevented collapse even as the mound compressed over centuries. What confuses researchers is the preservation environment. Scientists believe several factors contributed: low oxygen levels, stable internal humidity, clay ceiling layers, and compression from the mound itself. But none fully explain the chamber's condition. Comparable wooden tombs from similar periods across the Near East usually collapsed or decomposed long ago. Even more mysterious is the possibility that the builders intentionally engineered a controlled microclimate inside the mound. Some specialists argue the Phrygians may have understood passive humidity regulation through layered soil density and air restriction. Certain clay mixtures appear to have acted almost like natural insulation barriers. The burial chamber essentially functioned as a sealed preservation capsule. Modern comparisons make the mystery even more striking. Many medieval wooden structures from only 700–900 years ago have deteriorated far worse than the tumulus chamber. Some researchers compare the preservation conditions to the tomb of Xinjui in China, or the frozen Scythian tombs of Siberia, yet Gordian achieved remarkable preservation without ice, chemical embalming or permafrost. The burial feast discovered inside deepened the mystery further. Large bronze cauldrons, iron tools, wooden furniture, woven textiles, and residues of fermented beverages survived in extraordinary condition. Chemical analysis revealed evidence of a mixed alcoholic drink containing barley beer, grape wine, and honey mead. Some researchers recreated the recipe in modern laboratories, showing the Phrygians possessed advanced fermentation practices centuries before many later European brewing traditions. But perhaps the strangest detail is psychological rather than physical. The tomb does not feel improvised. Every structural element suggests planning, testing, and long-term design. Whoever built Tumulus understood load distribution, environmental control, timber selection, and burial sealing with a sophistication that feels unexpectedly modern for the Iron Age. At some point around 800 BCE, Gordian suffered a catastrophic fire. Excavations revealed thick destruction layers filled with ash, collapsed roofs, and carbonized debris. Temperatures during the blaze may have exceeded 800 degrees Celsius in some sectors. In most ancient cities, fires of that scale caused permanent decline, but Gordian rapidly rebuilt itself. The reconstruction phase shows evidence of improved urban planning. Streets became more organized, walls were thicker, storage systems expanded. Some buildings incorporated alternating timber and stone construction patterns that reduced cracking during thermal stress and seismic vibration. This is one of the site's biggest mysteries. The rebuilding process suggests the inhabitants learned from disaster and deliberately redesigned the city for resilience. Modern disaster engineering follows similar principles after earthquakes and urban fires. Flexible reinforcement, compartmentalized construction, distributed load-bearing systems, and controlled rebuilding layouts. Gordian appears to have implemented versions of these ideas nearly 3 millennia ago. Another unexplained feature of Gordian involves its storage infrastructure. Archaeologists uncovered large subterranean grain storage pits capable of preserving massive food reserves through harsh seasonal cycles. Central Anatolia experiences extreme environmental variation. Summer temperatures can exceed 35 degrees Celsius, while winters regularly drop below freezing. Yet the storage systems maintained relatively stable internal conditions. Researchers believe the pits exploited thermal inertia underground, minimizing temperature fluctuations naturally. Some also show evidence of carefully designed ventilation pathways that reduced moisture accumulation and prevented mold growth. The scale is equally important. Estimates suggest Gordian stored enough grain to support large populations or military forces for extended periods. This indicates not merely agricultural success, but logistical planning on a state level. Compared to many neighbouring Iron Age settlements, Gordian's storage network appears unusually centralised and technically organised. One of the most fascinating structures at Gordian is the so-called mosaic building. Its floor contains one of the oldest known pebble mosaic surfaces in the ancient world. At first glance, the patterns appear decorative, but detailed measurements revealed extraordinary geometric consistency. Thousands of pebbles were arranged into repeating angular motifs, with highly controlled symmetry across a large surface area. Creating such precision without modern measuring instruments would have been extremely difficult. Minor angular errors compound rapidly over distance, especially in large geometric layouts. Yet the builders maintained remarkable proportional accuracy. Some archaeologists believe this suggests advanced practical geometry knowledge among Phrygian craftsmen. Similar mathematical sophistication later became famous in classical Greek architecture, but Gordian predates many of those achievements. Do you think the engineers of ancient Gordian truly understood advanced construction techniques far beyond their time, or are we still missing part of the story? Share your thoughts in the comments below. Rising from the edge of Israel's Negev desert about 30 kilometers west of the Dead Sea, Tel Arad stands in one of the driest regions of the ancient Near East, where annual rainfall averages less than 100 millimeters. Permanent settlement in this environment should have been nearly impossible without advanced water management. Yet beneath layers of dust and collapsed stone, archaeologists uncovered evidence of a fortified city that survived for centuries against conditions that still challenge modern infrastructure. The site was first identified during surveys in the 20th century, but major excavations began in the 1960s under Israeli archaeologist Yohanan Aharoni. What emerged shocked researchers. Tel Arad was not a single settlement. It was a massive archaeological mound containing two entirely different cities from different eras. A large Canaanite urban centre from around the 3rd millennium BCE, and later an Iron Age Judahite fortress built nearly 2,000 years afterward. The deeper archaeologists dug, the stranger the site became. Sophisticated water systems appeared in terrain with almost no natural water source. Massive defensive walls revealed advanced engineering logic. Religious structures challenged long-held assumptions about ancient Judahite worship. Hundreds of inscriptions hinted at literacy levels far beyond what historians expected for a small desert kingdom. Tel Arad slowly transformed from a forgotten desert ruin into one of the most mysterious archaeological sites in the ancient Levant. The greatest mystery surrounding Tel Arad may be its survival itself. Ancient cities usually formed around rivers. Egypt depended on the Nile. Mesopotamian cities relied on the Tigris and Euphrates. Even smaller Levantine settlements typically emerged near springs or seasonal streams. Tel Arad had none of these advantages, yet archaeologists discovered a highly sophisticated hydraulic system, capable of collecting and storing enormous quantities of rainwater. The city used carefully engineered channels carved into the terrain to direct flash flood runoff into giant underground cisterns. Some reservoirs could hold hundreds of thousands of litres of water. The engineering precision is difficult to explain for such an early period. Water channels required extremely controlled gradients. If the angle was too steep, erosion would destroy the system. Too shallow, and water would stagnate or fail to reach storage areas. Modern hydrological studies show that even minor errors in slope calculation can collapse an entire desert collection network. At Tel Arad, many channels maintained remarkably stable flow patterns despite being constructed more than 4,000 years ago using primitive tools. Researchers also discovered evidence of sediment filtration systems. Smaller chambers trapped mud and debris before water entered the main reservoirs. This reduced contamination and preserved drinking supplies for longer periods. Similar filtration concepts would later appear in far more famous Roman hydraulic systems, yet Tel Arad predates many of them by over a millennium. Some engineers comparing ancient water technologies have noted similarities between Tel Arad and Nabatean desert systems at Petra. However, Petra flourished much later and benefited from more advanced masonry techniques. Tel Arad achieved comparable desert adaptation using simpler materials and far earlier technology. The question remains deeply unsettling. How did a Bronze Age settlement in an almost waterless desert develop hydraulic knowledge sophisticated enough to sustain urban life for centuries? Tel Arad was not only designed to survive drought, it was designed to survive war. Excavations revealed multiple defensive phases stacked almost perfectly on top of one another across centuries. At least 12 major occupation layers have been identified, yet many later walls aligned closely with earlier foundations despite the absence of modern surveying equipment. Some fortification walls exceeded 4 meters in thickness. Their internal structure suggests intentional shock absorption design. Outer layers of stone and mud brick absorbed impact energy, while inner cores stabilized the structure. Modern military engineers have compared this principle to layered defensive architecture used in later fortifications. The mud bricks themselves created another mystery. In desert environments, mud brick structures normally erode rapidly under cycles of heat, wind, and rare but destructive rainstorms. Yet many sections at Tel Arad survived in unusually good condition for more than 2,000 years. Laboratory analysis suggests ancient builders carefully optimized mixtures of clay, straw, ash, and mineral additives. Some samples show unusually dense microstructures that reduced cracking and moisture penetration. Similar durability has been observed at a few other Near Eastern sites, but the exact production formula remains unknown. This has led some materials scientists to speculate that ancient builders possessed empirical construction knowledge far more advanced than historians previously believed. They may not have understood chemistry in modern terms, but generations of experimentation could have produced highly refined engineering traditions lost over time. One of the most controversial discoveries at Tel Arad was hidden inside the Judahite fortress itself. Archaeologists uncovered a small temple remarkably similar in layout to descriptions of the first temple in Jerusalem. It contained an outer courtyard, sacrificial altar, inner sanctuary, and a Holy of Holies-like chamber. This created a major historical problem. According to traditional interpretations of biblical history, centralized worship should have been focused primarily in Jerusalem. Yet Tel Arad appeared to maintain its own organized temple complex deep in the desert frontier. The mysteries intensified in 2020 when residue analysis on 2 limestone altars produced extraordinary results. Researchers identified traces of frankincense on one altar and cannabinoid compounds on the other. Evidence suggested that a psychoactive substance may have been burned during ritual ceremonies. This discovery triggered major debate among historians and neuroscientists. Altered states of consciousness have appeared in many ancient religions worldwide, from Greek mystery cults to shamanic traditions in Central Asia. But direct physical evidence connecting psychoactive compounds to ancient Judahite worship was almost non-existent before Tel Arad. The implications are enormous. Did ancient priests intentionally manipulate human consciousness during rituals? Did they understand the neurological effects of specific plants? Or were these substances symbolic offerings rather than inhaled compounds? No definitive answer exists. Tel Arad occupied a strategically important position between Judah, the Negev desert, and trade routes toward the Dead Sea. From its elevated position, observers could monitor movement across vast distances. Some researchers believe Tel Arad formed part of a larger military signaling network, connecting multiple desert fortresses. The spacing between several Judahite strongholds appear unusually optimized for line-of-sight communication. Fire beacons, smoke signals, or reflective surfaces may have transmitted warnings rapidly across the frontier. This concept resembles a primitive optical communication network, essentially an ancient long-distance messaging system. But recreating such a system experimentally has revealed serious problems. Desert winds distort smoke patterns. Dust storms reduce visibility dramatically. Heat shimmer can disrupt distant visual signals. Maintaining reliable communication over tens of kilometers would have required careful coordination and environmental knowledge. Some military historians argue that the success of these systems may indicate a much higher level of organizational sophistication within the Kingdom of Judah than previously assumed. Tel Arad may not have been an isolated desert outpost. It may have been part of a coordinated frontier defense system operating with surprising efficiency. Perhaps the most revolutionary discoveries at Tel Arad were not walls or temples, but fragments of broken pottery. More than 100 ostraka, pottery shards containing ink inscriptions in ancient Hebrew, were recovered from the fortress. The texts included military orders, supply records, food distributions, wine shipments, and troop instructions. At first, scholars assumed only elite scribes could write such documents. Then computational handwriting analysis changed everything. Using artificial intelligence and forensic comparison methods, researchers concluded that multiple individuals likely wrote the inscriptions. This suggested literacy was not limited to a tiny administrative elite. Ordinary military officers and supply personnel may also have possessed writing skills. If true, this completely alters previous assumptions about education and governance in 7th century BCE Judah. Some historians now argue that the administrative complexity visible at Tel Arad indicates a far more organized state system than once believed. Maintaining logistics in a harsh desert fortress required accurate accounting, communication chains, and coordinated supply networks. This raises a disturbing possibility for archaeologists. If literacy and administration were already this advanced in remote frontier settlements, how much ancient technological and organizational knowledge has been underestimated elsewhere? Takamatsuzuka Tomb sits beneath a quiet hill in rural Japan, yet inside this tiny stone chamber, archaeologists discovered something almost impossible. Vivid wall paintings that survived more than 13 centuries in one of the most humid climates in East Asia. Even more mysterious, the tomb contains astronomical maps, mathematically aligned architecture, and preservation techniques so effective that the paintings remained safer before modern archaeologists opened the chamber in 1972. For many researchers, Takamatsuzuka is not just a burial site. It is evidence that elite Japan during the Asuka period may have possessed engineering, chemical, and astronomical knowledge, far more advanced than historians once believed. The tomb was officially excavated in 1972 after local residents reported unusual stone formations beneath a circular mound about 5 meters high and 18 meters wide. When archaeologists opened the chamber, they found a compact stone room measuring only around 2.6 meters long, but its walls were covered with brilliantly colored murals unlike anything previously discovered in Japan. The discovery shocked historians immediately. Japan's humid environment normally destroys ancient pigments rapidly, especially organic binders and mineral paints. Yet the Takamatsuzuka murals still displayed clear reds, blacks, whites, and blues after roughly 1,300 years underground. The site was soon designated a special historic site and one of Japan's greatest archaeological treasures. The greatest mystery of Takamatsuzuka is not the tomb itself. It is the survival of its colors. Inside the chamber, archaeologists found paintings of court ladies, celestial beasts, and astronomical symbols rendered with remarkable precision. Laboratory analysis later identified pigments such as cinnabar for red, azurite for blue, and carbon black for dark outlines. These were expensive and technically demanding materials even by continental Asian standards during the 7th and 8th centuries. The problem is that pigments like azurite are extremely vulnerable to moisture and chemical instability. In modern conservation science, maintaining mineral pigments often requires tightly controlled humidity systems. Yet Takamatsuzuka survived naturally underground for over a millennium. Researchers discovered that the tomb chamber had been sealed with astonishing precision. The stone blocks fit together so tightly that airflow was drastically reduced. Oxygen levels inside the chamber likely remained unusually stable for centuries, slowing oxidation and microbial growth. In effect, the builders may have accidentally or intentionally created a primitive climate-controlled vault. What makes the mystery deeper is what happened after the tomb was opened. Within only a few decades, fungi and bacteria began attacking the murals. Black mold spots spread rapidly across several paintings, despite modern preservation technology. By the early 2000s, conservators were forced to dismantle sections of the chamber and move the murals into controlled laboratory environments. This led to an uncomfortable conclusion. The ancient sealing methods may actually have protected the paintings more effectively than the initial modern conservation attempts. Comparisons are often made with tomb paintings in Egypt's Valley of the Kings, or the cave murals of Dunhuang in China. But unlike Egypt's dry desert environment, Takamatsuzuka existed in humid Japanese soil with annual rainfall often exceeding 1,300 millimeters. From a preservation standpoint, the survival of these murals is statistically extraordinary. Some conservation scientists estimate that without an unusually stable microclimate, pigments in such an environment should have deteriorated centuries earlier. Yet the faces, clothing folds, and color contrasts remained recognizable after 13 centuries underground. The tomb almost behaves like a sealed time capsule, engineered far ahead of its era. The chamber itself is another puzzle. Unlike ancient Egypt or Rome, early Japan was not famous for monumental stone engineering. Most major structures during the Asuka period were built primarily from wood. Yet Takamatsuzuka demonstrates stoneworking precision surprisingly comparable to Korean Goguryeo tombs and certain Tang dynasty burial chambers in China. The walls were assembled from carefully cut tough stone blocks with minimal gaps between them. Modern scans revealed remarkably flat joining surfaces, reducing airflow and water penetration. Some researchers argue that deviations between surfaces measure only a few millimeters in certain sections. This creates a difficult engineering question. How did builders working in a confined underground space achieve such accurate alignment without modern measuring tools? The tomb also raises logistical problems. Some stones weigh several hundred kilograms, yet there is little evidence of large-scale lifting systems or ramps. Moving heavy stone through narrow excavation corridors would have required careful planning and mechanical coordination. Even more mysterious is the balance between strength and isolation. The chamber remained structurally stable for over 1,300 years despite earthquakes, seasonal moisture expansion, and shifting soil pressure. Japan is one of the most seismically active regions on Earth, experiencing thousands of measurable earthquakes every year. Ancient builders somehow created a chamber capable of surviving this unstable environment for centuries. Painted across the ceiling is one of the oldest known astronomical representations in Japan. Golden star markers appear against a dark background, forming constellations connected to East Asian celestial traditions. At first glance, it resembles imported Chinese astronomical symbolism from the Tang dynasty, but closer examination revealed something more sophisticated. The arrangement appears intentionally adapted to the curved geometry of the chamber ceiling. This matters because translating a flat star map onto a curved surface without distorting relative positions requires geometric understanding. Even today, astronomers and cartographers deal with similar projection problems when converting celestial coordinates into visual maps. Some scholars believe the mural reflects direct transmission of advanced astronomical knowledge from China or the Korean peninsula. Others argue the Japanese court had already developed its own educated class capable of understanding celestial positioning for ritual, political, and calendrical purposes. The ceiling also connects to broader East Asian cosmology. Ancient rulers often linked political legitimacy to celestial order. In this sense, the tomb may have functioned not merely as a burial chamber, but as a symbolic model of the universe itself. The walls contain depictions of the four guardian beasts of East Asian cosmology: the azure dragon, white tiger, vermilion bird, and black tortoise. Each creature corresponds to a cardinal direction, a season, and a section of the sky. Their placement inside the tomb was not random. The orientation aligns closely with traditional cosmological systems used in China and Korea for geomancy and royal burials. This suggests the builders used astronomical observation during construction. Without magnetic surveying instruments or modern compasses, ancient engineers likely relied on solar positioning and stellar tracking to establish orientation. The precision is impressive considering the tomb's compact scale. Even small directional errors could disrupt symbolic alignment. Yet the chamber maintains a coherent cosmological arrangement that survived intact for centuries. The famous female figures painted inside the tomb may be the strongest evidence of cultural exchange across East Asia during the Asuka period. Their hairstyles, layered robes, facial proportions, and shading techniques strongly resemble Tang Dynasty artistic traditions and Goguryeo mural painting styles. Yet the paintings were created inside Japan. This has led historians to debate whether foreign artists participated directly in constructing the tomb. Some theories suggest immigrant craftsmen from the Korean peninsula brought specialized painting techniques to the Japanese court. Others believe elite Japanese artists studied continental methods and adapted them locally. Either explanation points towards something larger: a sophisticated international flow of knowledge, technology, and artistic methods moving across East Asia more than 1,300 years ago. In other words, Takamatsuzuka may represent not an isolated Japanese achievement, but part of an interconnected scientific and cultural network stretching across ancient Asia. To this day, the identity of the person buried inside Takamatsuzuka tomb remains unknown. The sophistication of the chamber suggests the occupant may have belonged to the imperial family or an elite noble connected to Tang China or the Korean peninsula. Who do you think was truly buried inside the Takamatsuzuka tomb? A royal prince, a foreign noble, or someone whose identity was intentionally erased from history? Share your theories in the comments below. Sanctuary of Panoyas sits high in the granite hills near Vila Real in northern Portugal, far from the monumental skyline of Rome or the polished marble sanctuaries of Greece. At first glance, the site looks incomplete, almost primitive scattered boulders, carved basins, channels cut into bare stone, and inscriptions etched directly into the rock itself. But when archaeologists began studying the sanctuary in detail, they realized Panoyas was not a ruined temple. It was something far stranger, a ritual complex engineered directly into solid granite, operating almost like a ceremonial machine. Even today, nearly 2,000 years after its construction, researchers still cannot fully explain how or why this place was designed with such precision. The first modern descriptions of Panoyas appeared in the 18th century, when local scholars documented mysterious Latin inscriptions carved into the stone. Early travelers assumed the site was a damaged Roman shrine, but excavations during the 20th century revealed something much more unusual. Beneath layers of soil and vegetation, archaeologists uncovered a network of carved basins, channels, cavities, and stairways spread across multiple granite outcrops. Each excavation season revealed another part of the system. One basin connected to a narrow drainage groove. Another led toward a lower platform blackened by ancient burning. Some cavities appeared designed to collect liquid, while others seemed intended for fire rituals. Then came the discovery that transformed Panoyas from a forgotten provincial shrine into one of the most mysterious ritual sites in Europe. Several inscriptions explicitly described sacrificial procedures. One inscription explained where animals were killed, another described where blood flowed, others identified the locations where organs were burned for the gods. Suddenly, archaeologists realized the carved channels were not decorative. They formed part of an operational ritual system designed to direct liquids and movement through the sanctuary with extraordinary control. That discovery created a deeper mystery. The entire complex had been cut directly into granite, one of the hardest common stones on Earth, measuring roughly 6 to 7 on the Mohs hardness scale. Granite is dramatically more difficult to shape than limestone, the material used in many Roman monuments. Yet Panoyas contains dozens of carved features spread across uneven terrain. Some basins are more than a meter deep. Several channels maintain consistent slopes across naturally fractured rock surfaces. Even today, granite quarrying requires steel tools, abrasives, and large amounts of labor. Creating Panoyas with Iron Age or Roman-era technology would have demanded an enormous workforce and exceptional planning. Archaeologists studying tool marks at the sanctuary noticed something unusual. Many cuts appear smoother and more controlled than typical Roman quarry marks. Instead of random hammer fractures, certain surfaces show signs of deliberate abrasion and leveling. Some researchers believe the builders may have used quartz sand mixed with water as an abrasive polishing system, slowly grinding the granite over years or decades. Similar techniques were proposed for ancient Egyptian granite works at Aswan and parts of the Serapeum of Saqqara, but Panoyas presents the same puzzle on a ritual landscape scale rather than inside a single monument. The layout itself is equally difficult to explain. Roman religious architecture was usually geometric and centralized. Temples were designed around symmetry, courtyards, and axial planning. Panoyas ignores nearly all of those conventions. The sanctuary spreads across natural rock formations in a fragmented pattern. Participants moving through the site would climb uneven stairways, pass through narrow stone corridors, and transition between different elevations before reaching the upper ritual areas. Some archaeologists believe this movement was intentional, not merely practical, but psychological. The sanctuary may have been designed to create a staged spiritual ascent, where physical movement through stone symbolized movement between worlds. As excavations expanded, researchers uncovered evidence suggesting Panoyas was not originally Roman at all. The sanctuary appears to combine Roman ritual inscriptions with much older indigenous traditions from Celtic Iberian cultures that occupied the region before Roman conquest. That possibility changed the interpretation of the site completely. Instead of building a new temple, Roman authorities may have adapted an already sacred prehistoric location. If true, portions of the granite carving system could predate Roman occupation by centuries. This theory gained attention because Panoyas resembles almost nothing else in the Roman world. Comparisons have been made to Celtic sanctuaries in Gaul, where rituals occurred outdoors near natural rock formations and springs rather than inside enclosed temples. Yet even those parallels fail to explain the engineering precision visible at Panoyas. Certain channels are only a few centimeters wide, but maintain remarkably stable flow gradients. Some basins appear positioned to maximize rainwater collection. Others align with natural depressions in ways that suggest the builders deeply understood the behavior of water across the granite surface. Modern laser scanning added another layer to the mystery. High-resolution surveys revealed that several carved lines maintained straighter trajectories than previously believed possible for freehand carving on irregular granite terrain. In some places, the cuts follow the rock's natural fracture patterns with astonishing efficiency, minimizing the amount of stone removal needed. This suggests the builders were not simply carving randomly into rock. They possessed detailed geological knowledge and intentionally exploited the granite's structural weaknesses to reduce labor. Another unexplained feature involves acoustics. visitors standing between certain rock formations at Panoyas experience unusually strong echo effects. Voices reflect sharply across the stone surfaces, especially during low wind conditions. Some researchers suspect the sanctuary's builders deliberately selected the site for its sound properties. During nighttime rituals illuminated by fire, chanting or ceremonial speech would have reverberated through the granite corridors, creating an overwhelming sensory experience. In this sense, Panoyas may have functioned less like a temple and more like a controlled ritual environment designed to manipulate sound, movement, light, and liquid simultaneously. The inscriptions themselves remain among the most extraordinary discoveries at the site. Ancient religious complexes rarely contain such direct operational descriptions, but at Panoyas, the texts almost read like ritual instructions. One inscription specifies that the blood of sacrificial animals was poured into designated cavities. Another identifies the exact area where entrails were burned. This level of procedural detail is extremely uncommon in Roman religious sites. It transforms the sanctuary from a symbolic sacred place into something closer to a functional ceremonial apparatus. And yet many parts of the system still make no sense. Some basins appear too small for sacrifice. Others lack obvious drainage paths. Several carved depressions seem positioned in impractical locations, unless wooden or metal structures once existed above them and later disappeared. Archaeologists suspect much of the sanctuary's original operational system may have included organic components that decayed long ago, leaving behind only the granite framework. Even the sanctuary's visual design raises questions. Unlike monumental Roman temples intended to dominate the landscape, Panoyas hides within it. The granite outcrops blend into the hillside, making the sanctuary difficult to recognize from a distance. This concealment may have been intentional. Some historians believe the rituals conducted there were restricted to initiates rather than public ceremonies. The fragmented layout, hidden basins, and isolated ritual stations would have reinforced secrecy and controlled access. What do you think Panoyas truly was, a Roman sanctuary, a forgotten prehistoric ritual machine, or something far more advanced than historians currently understand? Share your thoughts and theories in the comments below. Asos necropolis lies on the Aegean coast of northwestern Turkey, where thousands of stone coffins once left one ancient city and spread across the Roman world. But the greatest mystery was never the dead buried inside them. It was the stone itself. Ancient writers claimed bodies placed inside these sarcophagi decayed with unnatural speed, reducing to skeletons in only a few weeks. More than 2,000 years later, archaeologists still debate whether Asos accidentally discovered a form of natural biochemical decomposition centuries before modern science understood bacteria, minerals, or microbiology. The ruins of Asos were systematically identified by European travelers during the 18th and 19th centuries, but major excavations accelerated after the American archaeological campaigns, led by Joseph Thatcher Clark and Francis H. Bacon in the 1880s. As excavators cleared the necropolis surrounding the ancient city, they uncovered hundreds of massive stone sarcophagi carved from local volcanic andesite. Many were unfinished, others appeared prepared for export. What emerged was not simply a cemetery, but evidence of a large-scale industrial stone operation connected to Mediterranean trade routes more than 2,000 years ago. The first and most disturbing mystery became known in antiquity itself. Roman naturalist Pliny the Elder described Asos stone coffins as sarcophagi, literally flesh-eating stones. According to ancient accounts, corpses buried inside decomposed unusually fast, sometimes leaving only bones within roughly 40 days. While ancient writers often exaggerated, the persistence of the claim across multiple Roman sources suggests the phenomenon was widely observed rather than invented mythology. Modern geology offers partial explanations but not complete certainty. The sarcophagi were carved from volcanic andesite rich in minerals and microscopic pore networks. Unlike dense marble, porous volcanic stone can absorb moisture and accelerate airflow around organic material. Some researchers believe the rock may have created conditions favourable for aerobic bacterial activity, dramatically increasing decomposition rates. In effect, the stone may have functioned as a natural dehydration chamber combined with microbial acceleration. What makes this extraordinary is the historical context. Ancient civilizations usually obsessed over preserving bodies. Egyptians spent nearly 3,000 years refining mummification techniques designed to stop decay entirely. Natron salts removed moisture while resins sealed tissue against bacteria. Yet Asos appears to represent the opposite philosophy, accelerating destruction instead of preventing it. Two ancient cultures separated by geography and belief, both manipulated decomposition with remarkable effectiveness, one slowing time, the other speeding it up. Even today, forensic decomposition rates vary enormously depending on humidity, temperature, bacteria, oxygen, and soil chemistry. In modern outdoor conditions, full skeletal reduction can take months or years. Under dry desert conditions, tissue may naturally mummify instead of decomposing. Yet the Asos reputation persisted strongly enough that wealthy Romans imported these coffins across the Mediterranean specifically for burial. That implies the effect was visible enough to become commercially valuable. The second mystery involves the stoneworking itself. Andesite is significantly harder than limestone and much more difficult to carve. On the Mohs hardness scale, andesite often approaches hardness levels near basalt, meaning tools wear down rapidly during cutting. Yet Asos craftsmen produced enormous sarcophagi with relatively smooth interior walls, sharply cut edges, and fitted lids weighing multiple tons. Some unfinished examples reveal systematic quarrying methods rather than random carving. Workers appear to have separated blocks using channels and controlled fracture lines before shaping the coffins with iron chisels and hammerstones. The precision becomes difficult to explain at industrial scale. Producing a single massive coffin would already require immense labour. Asos produced hundreds. The logistics become even more mysterious when examining distribution patterns. Archaeologists have identified Asos sarcophagi far beyond the city itself, including sites in Alexandria, the Levant, Anatolia, and parts of the Balkans. Transporting multi-ton volcanic coffins through mountainous terrain toward coastal ports would have required advanced coordination systems. Even modern engineers recognize the difficulty of moving concentrated stone loads without cranes, hydraulic lifts, or mechanized transport. Ancient Roman merchant ships could carry heavy cargo, but loading operations remain difficult to reconstruct. Some historians believe large wooden treadwheel cranes may have been used in harbour zones, powered entirely by human walking motion inside rotating wheels. Others argue that ramps, rollers, sledges and compound pulley systems distributed the loads gradually. Yet no surviving written manual explains exactly how Asos exported stone coffins at such scale. Comparisons with other ancient transport mysteries are unavoidable. The unfinished obelisk at Aswan weighs more than 1,000 tons and demonstrates Egyptian stone-cutting ambition. The trilithon blocks of Baalbek each exceed 800 tons and still challenge modern explanations. Easter Island's Moai statues were transported across volcanic terrain using methods researchers continue debating today. Asos belongs to the same category of ancient engineering paradoxes. Societies with supposedly limited technology repeatedly handling materials modern construction teams would still respect. Another unresolved mystery surrounds the necropolis layout itself. In many ancient cities, the dead were deliberately positioned along approach roads so travellers entering the city would confront generations of ancestors before reaching the living population. At Asos, sarcophagi lined major access routes overlooking the Aegean Sea. Death became part of the urban landscape. Some archaeologists suspect this arrangement also served commercial purposes. Foreign merchants arriving by sea would immediately see enormous stone coffins displayed outside the city walls, effectively advertising Assos craftsmanship before trade negotiations even began. The necropolis may have functioned simultaneously as cemetery, monument, and industrial showroom. Environmental durability adds another layer of mystery. Assos sits within an active seismic region exposed to salt air, humidity shifts, and strong Aegean winds. Over 2 millennia, many softer stone structures across the Mediterranean suffered catastrophic erosion. Sandstone monuments at Petra lost enormous surface detail due to wind abrasion and water infiltration. Yet numerous Assos sarcophagi remained structurally recognizable despite constant coastal exposure. Geologists believe the volcanic composition of the andesite contributed to this survival. Fine-grained igneous rock often resists weather penetration better than porous sedimentary stone. However, durability alone does not fully explain the preservation quality. Some lid joints remain surprisingly stable despite centuries of earthquakes affecting western Anatolia. The industrial implications may be the most overlooked mystery of all. Assos was not merely carving isolated luxury tombs. Evidence suggests organized extraction zones, standardized coffin forms, labor specialization, and export coordination across international trade networks. In other words, the city operated something resembling a proto-industrial stone manufacturing economy centuries before the Industrial Revolution. That raises uncomfortable historical questions. Ancient societies are often imagined as technologically primitive compared to the modern world. Yet places like Assos repeatedly reveal systems of engineering organization, resource management, and material science that appear far more advanced than simplistic historical narratives suggest. The workers of Assos understood quarry stress, transport balance, stone durability, and decomposition behavior well enough to create products desired across an empire stretching thousands of kilometers. Do you think the people of Assos truly understood the strange properties of these flesh-eating stones? Or was it an ancient discovery they used without ever knowing the science behind it? Share your thoughts in the comments below. Overlooking the Valley of Elah around 30 kilometers southwest of Jerusalem, Kirbet Kayafa remained largely unnoticed until major excavations began in 2007 under archaeologists Yosef Garfinkel and Sar Ganor. Almost immediately, the excavation shocked researchers. Beneath layers of clapstone, archaeologists uncovered a heavily fortified Iron Age city dated by radiocarbon analysis to roughly 1020 to 980 BCE, the exact period traditionally associated with the rise of the Kingdom of Judah and the era of King David. What made the discovery explosive was not only the age of the city, but its sophistication. At a time when many scholars believed Judah was little more than scattered tribal settlements, Kirbet Kayafa revealed massive fortifications, advanced urban planning, standardized construction, and evidence of organized administration. The site appeared far too complex for the small pastoral society model that dominated earlier historical theories. The city covered roughly 2.3 hectares and was surrounded by nearly 700 meters of defensive walls. Archaeologists estimate that constructing the fortifications alone required around 200,000 tons of stone. For comparison, Many nearby Iron Age villages used mostly mud brick and simple fieldstone foundations. Kayafa instead looked like a purpose-built military fortress created by a centralized authority. And then came the strangest part. The city appears to have existed for only a few decades before being violently abandoned. One of the greatest mysteries surrounding Kirbet Kayafa is how quickly the city may have been constructed. Excavation layers suggest the settlement was not gradually expanded over centuries like most ancient towns. Instead, it seems to have appeared almost fully planned from the beginning. The walls were built using gigantic cyclopean stones, some weighing several tons each. Even today, moving such blocks uphill without cranes or modern lifting systems would require careful engineering and enormous manpower. Yet around the 10th century BCE, iron tools were still primitive in the region, and there is no evidence of advanced pulley systems similar to those later used by Greeks or Romans. Researchers believe the builders used earthen ramps, wooden sledges, leverage systems, and coordinated human labor. But those explanations only partially solve the problem. The terrain around the site is steep and rocky. Transporting thousands of heavy stones onto the hilltop would have required large labor forces, logistical planning, and constant food supply chains. Some archaeologists estimate that the workforce necessary for the project would have resembled the organization levels seen in early state societies such as Egypt or Assyria. That directly contradicts earlier theories that Judah at the time lacked centralized political power. The scale becomes even more mysterious when compared to neighboring settlements. Many nearby Philistine and Canaanite sites from the same period were either larger but less fortified, or heavily fortified but built over much longer timelines. Kayafa somehow achieved both speed and complexity simultaneously. The city's fortification system represents one of the most advanced military designs of the early Iron Age. Instead of a single thick wall, Kirbet Kayafa used a casemate wall system, 2 parallel stone walls with chambers between them. Those chambers could serve multiple purposes, including storage rooms, troop movement corridors, emergency shelters, and reinforcement spaces filled with earth during sieges. This was not simple village architecture, it was military engineering. What makes the system extraordinary is how integrated it was with civilian housing. Houses were physically attached to the fortification walls, creating a compact urban defense structure that maximized space while strengthening the perimeter. This level of urban planning is unusual for such an early date. Similar military layouts became more common centuries later, in Assyrian frontier forts, and even some Roman defensive outposts. The question is unavoidable. Who designed this system? Because Kirbet Kayafa does not look like an experimental settlement, it looks like the product of accumulated military knowledge. Some researchers argue that the city proves the existence of trained engineers or military architects in the southern Levant much earlier than previously believed. Kirbet Kayafa possesses something extremely rare for the period: 2 large fortified gates. This detail became internationally famous because the Hebrew biblical name Sha'arayim roughly translates to 2 gates. Very few Iron Age cities in the region had dual gates because multiple entrances created major defensive weaknesses. A second gate meant more soldiers were required, larger wall openings had to be protected, construction complexity increased, and the risk during attacks became significantly higher. Yet the builders intentionally included them. One gate faces west toward Philistine territory, while the other faces south toward the Judean highlands. Some historians believe the layout allowed rapid military deployment between frontier zones. Others argue the gates controlled trade movement across the Elah Valley. But another theory is even more intriguing. Some researchers suspect the dual gate system may have carried symbolic or political meaning. possibly representing authority over multiple territories or serving ceremonial functions connected to regional governance. No consensus exists today. In 2008, archaeologists uncovered one of the site's most controversial artifacts, the Kirbet Kayafa ostrakon. The artifact is a pottery shard covered with ink inscriptions written in an early alphabetic script, and debate immediately erupted over its meaning and language. If the text represents early Hebrew, it would suggest that literacy existed in Judah at a surprisingly advanced level during the 10th century BCE. That would imply the existence of trained scribes, bureaucratic systems, legal or military record-keeping, and organized administration. This is important because earlier academic models often portrayed Judah during this period as largely illiterate and politically fragmented. The ostrakon itself remains difficult to translate fully because the writing is faded and incomplete. Some scholars interpret it as a social or legal text discussing justice and protection of the poor, while others argue it may simply be practice writing. But regardless of interpretation, the existence of writing alone changes the historical picture dramatically. Combined with the city's fortifications and planning, the inscription suggests that Kirbet Kayafa belonged to a society far more organized than previously assumed. Another unresolved mystery is how the fortress sustained itself. Hilltop fortresses in the ancient Near East depended heavily on secure water systems, yet Kirbet Kayafa lacks the enormous underground water tunnels seen at places like Megiddo or Hazor. Despite this, excavations uncovered storage facilities, food preparation areas, large quantities of pottery, and evidence of sustained occupation. Maintaining a military garrison on the hill would have required reliable water access, grain storage, livestock support, and continuous resupply operations. Some archaeologists believe hidden cisterns or unexcavated channels may still exist beneath the site. Others think the city relied on seasonal water management systems that remain poorly understood. What makes the mystery worse is the climate. The region experiences long dry seasons, and prolonged siege conditions would have made survival extremely difficult without advanced planning. If Kayafa truly functioned as a frontier military fortress, its logistical systems may have been far more sophisticated than the archaeological remains currently reveal. Perhaps the strangest aspect of Kirbet Kayafa is how briefly it existed. Radiocarbon dating suggests the city flourished for only several decades before being abandoned or destroyed. Archaeologists found evidence of burning and structural collapse, but no clear explanation for why the settlement disappeared so quickly. This creates a major historical puzzle. Why would an emerging kingdom invest enormous resources into massive fortifications, advanced urban planning, military infrastructure, and organized administration only to abandon the site shortly afterward? Some theories suggest military defeat, political instability, shifting borders, changing trade routes, or collapse of centralized authority. Others believe the fortress may have been part of a short-lived expansion campaign against the Philistines. But the scale of the construction compared to its short lifespan remains difficult to explain. It is comparable to building a heavily fortified military base only to abandon it within a generation. In eastern Anatolia, beside the immense blue waters of Lake Van, a wall of stone rises abruptly from the landscape. At first glance, it looks less like a fortress and more like a natural mountain split open by geological violence. But carved into the side of that cliff are stairways, chambers, inscriptions, and defensive walls belonging to Tushpa Fortress, the ancient capital of the Urartian kingdom, built nearly 3,000 years ago. What makes Tushpa so unsettling is not simply its age, it is the engineering. Even today, archaeologists and structural historians still debate how a civilization of the early Iron Age managed to carve, transport and construct on terrain that modern engineers would consider extremely hostile. The first large-scale modern investigations of Tushpa began in the 19th century when European explorers travelling through the Ottoman Empire documented strange inscriptions cut high into the cliffs above Van. Early travellers believed the ruins belonged to Assyrians because the writing resembled Mesopotamian cuneiform. But in the 1820s and later through expeditions in the 1870s, researchers discovered that the inscriptions referenced kings of a previously misunderstood civilization, Urartu. Each excavation season revealed something new. One expedition uncovered rock-cut royal tombs hidden deep within the mountain. Another revealed massive cisterns and hydraulic channels. Later surveys found defensive terraces and stone foundations stretching across the cliffside, proving that Tushpa had once been a heavily fortified royal complex rather than a simple military outpost. The deeper archaeologists dug into Tushpa, the stranger the fortress became. The first mystery was the mountain itself. The citadel stands on a limestone ridge more than 100 meters high and nearly 2 kilometers long. The slopes are steep enough that in many areas even modern climbing equipment is required for safe access. Yet the Urartians somehow transformed this natural rock formation into a functioning royal capital. They carved staircases directly into vertical stone faces, some with remarkably even step geometry, despite severe erosion over thousands of years. In certain sections, the cuts are so straight that researchers compared them to later Roman quarrying techniques, even though the Romans would not dominate Anatolia until centuries later. This is where the technological debate begins. Iron Age tools in the 9th century BCE were still relatively primitive compared to later classical civilizations. Experimental archaeologists attempting to reproduce Urartian stone-cutting methods found that shaping hard limestone with early iron chisels required enormous labour and produced inconsistent surfaces. But many chambers in Tushpa display unusually smooth internal walls and sharply defined angles. Some cuts run several meters with almost no visible deviation. That level of precision becomes even more difficult to explain, considering many of these chambers were carved in confined spaces with minimal natural light. Among the most mysterious discoveries were the royal tomb chambers hidden inside the rock. These rooms were not built with stacked stone blocks like Egyptian pyramids or Mycenaean tombs. Instead, they were excavated directly into the mountain itself. The entrances are positioned high above the ground, accessible only through narrow carved pathways. Archaeologists still debate how workers transported tools, food, water, and illumination equipment into those spaces during construction. Some tombs contain ceilings and corners, approaching near-perfect geometric symmetry. Even slight angular errors during excavation would have ruined the chambers permanently because the rooms were carved from solid bedrock rather than assembled piece by piece. The engineering challenge becomes even more astonishing when compared to other ancient cliff structures. Persian royal tombs at Naqsh-e-Rostam also used rock-cut architecture, but most date centuries later than Tushpa. Egyptian burial chambers often relied on broader excavation corridors and flatter terrain. Tushpa combined elevation, confined carving spaces, and steep mountain geometry all at once, making the fortress one of the most technically difficult construction sites of the ancient Near East. Then came the water mystery. Tushpa overlooks Lake Van, but the fortress itself sits far above the shoreline on dry, exposed stone. A large settlement at that elevation would require enormous quantities of water for drinking, storage, livestock and defense. Yet excavations uncovered reservoirs, cisterns, and evidence of sophisticated hydraulic systems integrated into the fortress. Researchers believe the Urartians connected Tushpa to broader canal networks built throughout the kingdom. The most famous example is the Menua Canal, an engineering project more than 50 kilometers long that still carries water in some areas nearly 28 centuries later. What astonishes engineers is the precision of those gradients. Modern hydraulic analysis showed that several Eurasian canals maintained carefully controlled slopes that allowed water to flow steadily without destroying the channel walls through erosion. In some sections, the incline variation is measured in fractions of a degree across long distances. Comparable hydraulic accuracy would later become famous in Roman aqueduct systems. Yet the Urartians achieved similar functionality centuries earlier in mountainous terrain, using surveying methods that remain poorly understood. Some archaeologists believe the Urartians used primitive astronomical alignment and long-distance sighting techniques to calculate elevation changes. Others argue they developed practical engineering traditions through generations of trial and error. But no theory fully explains how such precise hydraulic control was maintained over rugged volcanic terrain without advanced instruments. But Tushpa's greatest strength may have been its military engineering. Most ancient fortresses relied on walls. Tushpa weaponized geography itself. Instead of leveling the mountain, the Urartians modified the terrain to create defensive choke points, steep approach corridors, and elevated firing positions. Certain access routes force attackers into narrow, exposed pathways, overlooked from above. Military historians have compared aspects of Tushpa's defensive logic to medieval hill fortresses built over 1,000 years later. The difference is that Urartu developed these concepts during a period when organized siege warfare was still evolving across much of the Near East. The layout suggests a sophisticated understanding of visibility, movement restriction, and terrain manipulation. Even today, modern soldiers studying ancient warfare note that assaulting Tushpa directly would have been devastatingly difficult without prolonged siege tactics. In many places, gravity itself became part of the fortress defense system. Excavators also discovered enormous stone blocks positioned in places that remain difficult to explain. Some wall sections contain multi-ton stones transported onto elevated terraces where maneuvering space is extremely limited. The region surrounding Lake Van is rugged, uneven, and prone to severe winter conditions. Traditional theories suggest the Urartians used wooden rollers, sledges, and earthen ramps. However, no experimental reconstruction has fully demonstrated how those techniques could consistently move such heavy material onto the steepest areas of the fortress without catastrophic collapse or loss of control. Comparisons with Inca stone transport in Peru often emerge in academic discussions because both civilizations operated in mountainous environments. But while the Inca relied heavily on polygonal masonry and broader mountain roads, Tushpa's terrain is narrower and more vertically restrictive. That difference makes the logistics of Urartian construction even harder to reconstruct experimentally. Adding to the mystery are the inscriptions carved directly into exposed cliff faces. One of the most famous texts belongs to King Sarduri. The inscription sits high above the ground in a location so difficult to access that early travelers required ropes just to approach it. Yet the cuneiform characters are strikingly uniform in depth and spacing. Creating such inscriptions would have required stable platforms or scaffolding systems, but almost no physical evidence of those support structures survived. Historians suspect the Urartians developed advanced wooden scaffolding techniques adapted specifically for cliff construction, though the exact methods remain unknown. The precision of the inscriptions is especially important because uneven carving on exposed stone normally leads to accelerated erosion. Yet many Urartian characters remain legible after nearly 3,000 years of wind exposure, temperature shifts, and seismic activity around Lake Van. Fulak Fiad was never discovered in a single dramatic excavation like Tutankhamun's tomb or Pompeii. Instead, archaeologists slowly realised that strange blackened mounds scattered across Ireland were all part of the same ancient phenomenon. More than 4,000 sites have now been identified, making Fulak Fiad one of the most common archaeological structures in Ireland. Most were found during peat cutting, road construction, or aerial surveys. Farmers repeatedly uncovered layers of cracked stone mixed with charcoal near streams and marshes. Early archaeologists initially dismissed them as simple refuse dumps. But by the 20th century, excavations revealed a repeating pattern almost everywhere. A horseshoe-shaped mound of heat-shattered stones surrounding a wooden or stone-lined trough filled with water. Radiocarbon dating placed many sites between 2000, 200 and 500 BCE during the Bronze Age. That immediately created a mystery. Bronze Age Ireland was not an urban civilization like Egypt or Mesopotamia. It had no monumental stone cities, no pyramids, and no large written record. Yet somehow, people across the island were operating what appeared to be a massive thermal processing network for nearly 2,000 years. Some Fulak Fiad sites contain several tons of burned sandstone fractured by extreme temperature change. In a few locations, archaeologists estimated that hundreds of thousands of stones had been heated and discarded over centuries. The scale suggests repeated industrial-level activity rather than occasional cooking fires. Even more mysterious is their geographic distribution. Many sites appear in isolated wetlands far from permanent settlements. Others are clustered unusually close together, almost like specialized production zones. This raised a question that still remains unanswered today. What exactly were Bronze Age people in Ireland doing with enormous quantities of boiling water? Excavations revealed that the heart of every Fulak Fiad was a trough capable of holding large volumes of water. Some were carved from massive oak trunks. Others were constructed using wooden planks sealed with clay. Nearby sat fire pits filled with stones blackened by repeated heating. Archaeologists eventually reconstructed how the system likely worked. Stones were heated in large fires until reaching temperatures between approximately 600 and 900 degrees Celsius. The glowing rocks were then transferred into water-filled troughs, rapidly heating the water to near boiling point. Experimental archaeology produced astonishing results. In several modern reconstructions, researchers managed to heat more than 300 litres of water to nearly 100 degrees Celsius within minutes, using only heated stones. Meat could be cooked efficiently without metal cauldrons. Water temperatures could be maintained for hours by continuously replacing cooled rocks. The engineering implications are far more impressive than they first appear. Water absorbs heat slowly and requires massive energy transfer to reach boiling temperature. Modern thermodynamic calculations show that sustaining repeated boiling cycles at this scale would require careful management of fuel, stone selection, water flow, and thermal shock resistance. Not all rocks could survive the process. Many stones explode violently when rapidly heated and cooled. Yet Fulak Fiad builders repeatedly selected specific local sandstone types that fractured predictably without catastrophic bursting. Some researchers believe Bronze Age workers possessed practical thermal material knowledge developed through centuries of experimentation. The wooden troughs themselves are equally mysterious. Exposing wood to near boiling water repeatedly should warp and split the structure. Yet several excavated troughs show remarkable durability. Oak timbers preserved in bog environments reveal sophisticated carpentry joints and waterproofing techniques, despite the absence of iron nails or modern sealants. To some engineers, Fulak Fiad represents an overlooked form of prehistoric thermal engineering, a system optimized entirely through empirical knowledge long before formal science existed. Each major excavation seemed to deepen the mystery rather than solve it. At Ballyverney in County Cork, archaeologists uncovered preserved wooden troughs alongside thick charcoal deposits, confirming that controlled heating played a central role. But very few food remains were found nearby. At sites in County Clare and County Galway, excavators discovered sophisticated water management systems. Some troughs were connected to channels that continuously refreshed water from nearby streams. That suggested sustained large-scale operation rather than occasional feasting. At Rathpatrick in County Kilkenny, evidence emerged of temporary shelters built beside the burned mounds. This implied that people may have spent extended periods operating the sites, yet no clear evidence of villages or permanent habitation appeared nearby. One of the strangest discoveries came when microscopic analysis revealed surprisingly low concentrations of animal fat residues at several sites. If these places were primarily cooking facilities, archaeologists expected far more biological remains. Instead, some Fulak Fiad sites contained chemical traces associated with plant processing, leather treatment, or brewing activity. This triggered a wave of alternative theories. Perhaps the sites functioned as giant prehistoric breweries. Experimental archaeologists demonstrated that heated stones could maintain temperatures ideal for mashing grain during beer production. Others proposed that the boiling water was used for tanning hides or processing textiles. Another theory suggested ritual use. Fire and water held enormous symbolic importance in Bronze Age Europe. Some Fulak Fiad were deliberately placed in liminal landscapes, marshes, bog edges, and river crossings locations frequently associated with ritual deposition in ancient Celtic culture. Yet none of the theories fully explains all known evidence. Some sites are too large for ordinary cooking. Others lack industrial waste, expected from tanning or brewing. The same structure appears to have been adapted for multiple functions across different regions and centuries. That versatility may itself be the key to the mystery. The sheer number of Fulak Fiad sites forces archaeologists to reconsider how technologically advanced Bronze Age Ireland may actually have been. Unlike Stonehenge or the pyramids, Fulak Fiad left no towering monuments. Their technology was based on energy management rather than massive architecture. But in terms of labour and resource consumption, the scale may have rivaled far more famous ancient projects. Some burned mounds measure over 30 metres across and contain layers accumulated through centuries of operation. Researchers estimate that certain sites processed thousands of heating cycles over their lifetimes. This required enormous quantities of wood fuel. One study estimated that maintaining regular boiling operations at larger sites could consume several tons of timber annually. Across thousands of locations, the environmental impact would have been immense. That raises another mystery. Why would Bronze Age communities invest so much labour and fuel into this technology for nearly 2 millennia? The answer may lie in specialisation. Archaeologists increasingly suspect that Fulak Fiad formed part of a decentralised production network. Different sites may have served different purposes depending on geography, water supply, nearby resources, and seasonal activity. Some may indeed have been cooking centres during large gatherings. Others could have processed leather, brewed alcohol, extracted animal fats, steamed textiles, or even produced salt through evaporation techniques. If true, Fulak Fiad was not a single-purpose invention but an adaptable thermal platform, a Bronze Age technology system flexible enough to support multiple industries long before mechanized civilization emerged. Around the beginning of the Iron Age, Fulak Fiad sites gradually disappeared from the archaeological record. After nearly 2,000 years of widespread use, the technology was suddenly abandoned. No written explanation survives. No mythology clearly describes their true purpose. Unlike Roman baths or medieval furnaces, Fulak Fiad vanished almost silently from history. This disappearance is one of the strongest arguments that these sites were more technologically significant than they appear. Technologies that persist for centuries usually solve important economic or social problems. Fulak Fiad survived for almost as long as the Egyptian pyramid building era, yet modern civilization still cannot say with certainty what they were primarily designed to do. Dry highlands in central Turkey, nearly 1,500 meters above sea level, conceal enormous stone walls stretching across the Anatolian plateau, like the remains of a forgotten fortress city. For centuries, these ruins were believed to belong to a relatively minor settlement. That changed in the late 20th century when archaeologists began systematic surveys using aerial photography, satellite imaging, and large-scale geomagnetic scanning. What emerged beneath the soil shocked researchers. Hidden under the landscape was an enormous planned city covering nearly 2.5 square kilometers, surrounded by more than 7 kilometers of defensive walls, reinforced by hundreds of towers and gates. The city appeared to have been built rapidly during the 6th century BCE and then destroyed by fire only a short time later. Unlike most ancient cities that evolved gradually over centuries, Kirkines seemed to appear almost fully formed from the beginning. That single detail transformed the site into one of the strangest archaeological mysteries in Anatolia. The first mystery surrounding Kirkines is the sheer speed and scale of its construction. Archaeologists estimate that the outer fortification walls alone required millions of stones. Some wall sections were more than 4 meters thick, extending across rugged hills and steep terrain with remarkable consistency. For comparison, many fortified Iron Age cities in Anatolia, far smaller and developed incrementally over generations. Kirkines, however, resembles a sudden state engineering project more comparable to imperial capitals of Assyria or later Persian administrative centres. The logistical problem becomes almost difficult to comprehend. Without cranes, industrial metal tools, or wheeled transport systems capable of handling heavy stone efficiently across mountainous terrain, ancient builders somehow organized labor, quarrying, transport, and construction on a gigantic scale. Researchers studying labor estimates suggest that, even with thousands of workers operating simultaneously, construction may have required an extremely centralized authority with advanced planning systems. The city's uniformity strongly implies pre-designed urban engineering rather than organic growth. That level of coordination in Iron Age Anatolia remains deeply unusual. Kirkines does not merely look defensive, it appears engineered entirely around military logic. The walls zigzag across the plateau instead of following simple straight lines, creating overlapping defensive angles that allowed defenders to attack invaders from multiple directions simultaneously. Many medieval fortresses later adopted similar principles, yet Kirkines demonstrates them centuries earlier. The gates are equally mysterious. Instead of wide, direct entrances, several access points force movement through narrow turning passages where invading forces would become trapped and exposed. Archaeologists believe these choke point systems were intentionally designed to maximize defensive advantage. What makes this strange is that neighboring cultures of the same era often relied on much simpler defensive architecture. Kirkines suggests a society with unusually advanced understanding of battlefield geometry and controlled urban defense. Some researchers even compare the city's layout to a giant engineered security system rather than a conventional settlement. One of the most revolutionary aspects of Kirkines is how modern technology revealed the city without excavation. Archaeologists used magnetometry surveys capable of detecting buried stone structures and burnt materials beneath the ground. The results exposed an entire hidden urban grid. Streets, districts, compounds, workshops, and ceremonial areas appeared with astonishing clarity. The scans revealed something even more puzzling. The city followed a highly organized plan. Roads intersected in controlled patterns, major structures occupied strategic positions, and the urban design appeared coordinated across the entire settlement. Ancient cities usually evolve unevenly over centuries, producing chaotic layouts. Kirkines instead resembles a modern planned capital, designed from the beginning according to a master blueprint. This raises a disturbing historical question. If Iron Age builders in Anatolia could organize urban planning at this level, how many other primitive civilizations may have possessed forms of engineering sophistication that archaeology still underestimates? At some point in the 6th century BCE, Kirkines was consumed by a massive fire. Thick destruction layers and burned debris appear across large sections of the city. Yet the most mysterious detail is what happened afterward. Almost nothing. Most strategically located ancient cities were rebuilt repeatedly after destruction. Troy was reconstructed multiple times. Babylon survived successive invasions. Hatassah rose and fell across different eras. Kirkines, however, was largely abandoned forever. This is extremely unusual considering its enormous walls and dominant position overlooking the Anatolian plateau. Archaeologists still debate whether the city was destroyed during warfare, internal collapse, or deliberate evacuation followed by systematic burning. Some theories connect the destruction to the expansion of the Persian Empire under Cyrus the Great, while others associate it with regional political collapse. But no explanation fully clarifies why such an enormous and expensive city vanished almost instantly from history. Another unresolved mystery is sustainability. Kirkines stood in a relatively harsh environment where maintaining a large urban population would have been difficult. Ancient cities depended entirely on reliable supplies of water, timber, grain, livestock and fuel. Yet evidence suggests Kirkines may have supported thousands of inhabitants within fortified walls. The engineering challenge becomes enormous when compared to similar settlements. Researchers estimate that ancient urban populations required vast quantities of food transported constantly from surrounding agricultural zones. Water management alone would have been critical. However, archaeologists have not fully explained how Kirkines sustained itself logistically during its short existence. This has led some historians to propose that Kirkines may not have functioned as a traditional permanent city at all. Instead, it may have operated as a massive military administrative centre or emergency royal capital designed for strategic control during periods of regional instability. If true, the city may represent one of the earliest examples of large-scale temporary geopolitical engineering in ancient Anatolia. Several parts of Kirkines appear aligned carefully with the surrounding terrain and defensive sightlines. Elevated structures command wide views over the plateau, while road systems seem optimized for controlled movement across the city. This level of urban precision is particularly strange because it emerged in an era supposedly limited by relatively primitive surveying methods. Ancient engineers likely relied on ropes, wooden measuring rods, solar observations, and manual geometry, yet the resulting city demonstrates remarkable consistency across enormous distances. Comparisons are often made with other ancient planned cities such as Mohenjo-Daro in the Indus Valley, or the orthogonal street systems later perfected by the Romans. However, Kirkines differs because it combines planned urbanism with extreme militarization. The city feels less like a civilian settlement and more like a giant strategic instrument embedded directly into the landscape. Perhaps the greatest mystery is the identity of the people who built it. Some archaeologists associate Kirkines with the Medes, an Iranian people who briefly dominated parts of Anatolia before the Persian Empire emerged. Others argue the city may represent a local Anatolian power attempting to imitate imperial models from Assyria and Mesopotamia. The uncertainty matters because Kirkines seems too ambitious for an ordinary regional kingdom. Building a city of this scale required immense labour organisation, political authority, engineering knowledge, and economic resources. Whoever constructed Kirkines possessed capabilities far beyond what historians once assumed for Iron Age Anatolia, and yet the civilization behind the city left surprisingly little written evidence. No surviving inscriptions fully explain its purpose, rulers, or sudden destruction. The city remains largely silent. What do you think Kirkines really was? A forgotten imperial capital, a giant military experiment, or evidence that ancient engineering was far more advanced than we realize? Share your thoughts in the comments below. La Cabana Fortress rises above the entrance of Havana Bay like a stone wall built for an empire that feared the entire Caribbean collapsing around it. Constructed by Spain after the British captured Havana in 1762, the fortress stretches across more than 700 meters of elevated coastline and once housed thousands of soldiers and cannons. But the real mystery is not its size. It is the fact that this massive structure was built on unstable coastal limestone, exposed to salt water, hurricanes, tropical humidity, artillery fire, and centuries of erosion. Yet large sections still remain structurally intact more than 250 years later. Modern engineers studying the fortress discovered something unsettling. Many of its construction techniques appear surprisingly advanced for the 18th century, resembling ideas used in modern military engineering, passive cooling systems, hydraulic management, and even self-repairing construction materials. After Britain briefly seized Havana during the 7 Years' War, Spain realized the city's defenses were catastrophically vulnerable. In response, Spanish military engineers began constructing La Cabana in 1763 on a rocky ridge overlooking the harbour. Historical records estimate that thousands of workers, enslaved labourers, and military engineers spent more than a decade completing the fortress. At first, historians viewed La Cabana as simply another colonial stronghold, but 20th century archaeological surveys and structural analyses began revealing anomalies beneath the walls. Engineers found unusually sophisticated drainage systems, strangely resilient mortar compositions, and geometric defensive designs that seemed far ahead of their time. The deeper researchers looked, the more the fortress resembled a giant engineering experiment hidden inside a military structure. One of the greatest mysteries surrounding La Cabana is how it was able to survive at all on its original foundation. The fortress sits atop karst limestone, a porous geological formation filled with underground cavities, fractures, and weak zones caused by water erosion. Even modern construction projects struggle on karst terrain, because heavy structures can collapse into hidden voids beneath the surface. Yet La Cabana carries millions of kilograms of stone across this unstable ground, with surprisingly little large-scale deformation. Geological surveys suggest Spanish engineers may have created layered compression foundations using crushed coral, compacted lime, clay mixtures, and interlocking stone beds that distributed pressure across wider areas. Some researchers compare the system to primitive forms of modern load dispersal foundations used in coastal engineering today. What makes this remarkable is timing. Soil mechanics as a scientific discipline did not formally emerge until the 19th and 20th centuries. Yet La Cabana's builders appear to have understood concepts related to weight distribution, vibration absorption, and terrain stabilization generations earlier. Several structural engineers who modeled the fortress digitally concluded that certain retaining walls may intentionally flex slightly during seismic vibrations and ground movement rather than resisting rigidly. That flexibility may be one reason the structure survived for centuries while many rigid colonial buildings collapsed elsewhere in the Caribbean. The fortress walls themselves contain another mystery. At first glance, they appear like ordinary defensive barriers. But ballistic simulations performed by military historians revealed something unusual about their geometry. Many outer walls are angled in ways that reduce the direct transfer of kinetic energy from cannon impacts. Instead of receiving artillery force head-on, the sloped surfaces redirect part of the impact sideways. In modern engineering, this principle is similar to energy dissipation geometry used in blast-resistant structures. Some simulations suggest certain wall sections could reduce destructive impact forces by nearly 40% compared to flat vertical walls of similar thickness. The walls were also built extraordinarily thick in some areas, exceeding 6 meters. Combined with internal earth-filled reinforcement zones, they acted almost like primitive shock absorbers. This becomes even more impressive when considering 18th century limitations. There were no computers, no modern stress calculations, and no digital modelling software. Yet the fortress demonstrates a surprisingly advanced understanding of force behaviour under repeated bombardment. Historians still debate whether these features came from accumulated battlefield experience or from engineering principles now partially forgotten. Beneath La Cabana lies a maze of tunnels, chambers, storage vaults, and gunpowder rooms that continue to puzzle researchers. Havana's climate creates enormous engineering problems for black powder storage. Average humidity levels often exceed 80%, conditions capable of destroying gunpowder effectiveness within relatively short periods. Yet Spanish military documents indicate that La Cabana stored enormous quantities of powder while maintaining operational readiness for long periods. Modern airflow studies suggest the fortress used passive ventilation techniques based on temperature differences between shaded stone chambers and ocean-facing air inlets. Cold air moved through lower tunnels while warmer air escaped through elevated openings, creating a continuous circulation system without mechanical assistance. In some chambers, airflow remains detectable even today. Architectural historians compare the design to passive cooling systems used in Middle Eastern wind towers and modern sustainable architecture. However, La Cabana integrated these concepts into a massive military fortress centuries before climate-controlled infrastructure existed. Some underground sections also appear positioned to minimize moisture condensation naturally. That level of environmental control suggests the builders understood humidity behavior far better than previously believed. Perhaps the most controversial mystery at La Cabana involves its mortar. Most coastal fortresses exposed to salt water and humidity eventually suffer catastrophic cracking. Salt penetrates microscopic fractures, expands over time, and weakens structural bonds. This process destroys countless historical buildings worldwide, but many sections of La Cabana show an unusual phenomenon. Tiny cracks inside the mortar appear partially resealed by newly formed mineral deposits. Laboratory analysis found that the fortress mortar contains high concentrations of lime, coral fragments, volcanic minerals, and microscopic calcium-rich particles. When seawater enters small fractures, chemical reactions trigger calcite crystal growth inside the cracks themselves. In other words, the material may slowly repair portions of its own damage. Modern material scientists call similar behavior autogenous healing or self-healing lime mortar. Researchers today are actively attempting to recreate such systems for sustainable concrete technology because global concrete deterioration costs hundreds of billions of dollars annually. What makes La Cabana extraordinary is that its builders may have accidentally, or intentionally, created a primitive version of this process over 2 centuries ago. Some mortar samples demonstrated compressive durability far exceeding expectations for materials continuously exposed to tropical marine conditions. In several areas, the inner structural core remained surprisingly dense despite visible surface erosion. Comparisons are often made with Roman marine concrete, which also grows stronger over time through seawater-triggered mineral reactions. Roman harbour structures have survived nearly 2,000 years. partly because volcanic ash mixtures formed durable crystalline compounds inside the concrete. La Cabana may represent a similar phenomenon in the Caribbean world, a forgotten material technology hidden inside colonial architecture. To this day, researchers still debate whether the formula resulted from deliberate experimentation or fortunate coincidence. A fortress under siege could survive only as long as its water supply lasted. Archaeologists discovered that La Cabana contains an elaborate rainwater harvesting and underground storage system, connected by carefully angled channels. Water moved entirely through gravity without pumps or mechanical lifting systems. Several reservoirs remained functional even after centuries. Hydraulic specialists studying the system noted that some channel gradients appear remarkably precise, maintaining controlled water flow while minimizing sediment accumulation. Similar engineering principles were used in Roman aqueducts and Persian qanat systems. The existence of such sophisticated water management inside a Caribbean military fortress demonstrates that the builders were not merely constructing walls. They were engineering a self-sustaining defensive machine. What do you think made La Cabana so advanced for its time? Forgotten engineering knowledge, lost materials technology, or something historians still haven't fully understood? Let us know your thoughts in the comments below.